Yeah. And we're live. Hello, everyone. Welcome to the. I'm sorry, I have the wrong banner here. Yeah, welcome to the Multifamily Housing Division presentations. My name is Srijit, and I will be the jury coordinator for this division. And it's my job to keep us on time, and I'll be taking this very seriously. Our finalist teams have put in a lot of hard work, and they've submitted their project reports about a month ago. And today, these teams will present their work to the jury. The MFY division has 3 jury members with expertise in net zero and resilient buildings. We have Dheeraj Wadhwa. He's a director at Carrier Corporation. He's currently responsible for the commercial businesses in India region and the overseas business. He's a mechanical engineer with a postgraduate diploma in business management. Hi, Dheeraj.
Hi, good morning, everyone, and best wishes to the
Next,
teams.
yeah, yeah. Next, we have Jitin. He's an architect and a teacher based in Mumbai. He has been involved in a range of architectural and research projects pertaining to sustainability since 1994. Hi, Jitin.
Hi everyone, and wish you all the best.
A third jury member is Samit Baumik. He's a co-founder at Veeratatva, a collaborative consulting firm that specializes in high-performance, sustainable building designs at little or no additional cost. He's a mechanical engineer with over 20 years of experience, and he's very passionate about performance-based design. Hi, Samit.
Hi, good morning, everyone.
Yeah. So these jury members have had over 2 weeks to review the reports submitted by the teams. They have looked at your work in detail and have already assessed your entries for the 10 contests of the decathlon. So students, your presentation will help them hear your narrative, and they will assess your presentation and your mastery over your solution through the Q&A session that will follow. They may revise their scores based on what they hear from you today. So our first presentation here today is from Team Avisa. They have worked on Superna Medarishil in Ahmedabad, Gujarat, and their project partner is Savvy Infrastructure Private Limited. So let's do a quick AV check for our presenters. Shravani, are you here? And can you turn on your mic and cam?
Hello, sir. Good morning.
Yeah, we can hear you loud and clear. Gauri, can you do a quick hello so that we can check your mic? Gauri is not here. Okay, Purva, you can go next.
Hi, good morning, sir. Can you hear me?
There seems to be a little bit of feedback, but
Now can you hear me?
yes, yeah.
Okay.
And Neil, can you turn on your mic and say something?
Yes, hello.
Right, great. So can we go into the presentation mode? Can you share your screen and go into presentation mode?
Yes, sure. I'll share my screen. Oh, yes. Can you see my screen?
Yes. Can you go into presentation mode?
Yeah.
Okay.
Yeah.
Okay. So team, you will have 25 minutes to present your work to the jury today. And at 20 minutes, I will ring a signal like this. You heard that? Yeah. And you won't have a 26th minute. So which means at 25 minutes, I'll need to cut you off. I'll need to stop you and ask you to end your presentation. So try to keep it within that 25 minutes. And after that, we'll have about 15 minutes of question answer session. And please keep your answers direct and to the point. Yep. If your project partner is here, we'll try to add them onto the stream as well. All right. So can you go into your slideshow?
Yes, yes, I'll go into the slide. You can see the screen, right?
Yes, yes.
Yeah. Yeah.
So there is a request that Gauri is in the backstage. Can you please add her?
We don't see her.
I am unable.
Okay.
So, guys, I think you can get started maybe.
Excuse me, just a second. Give me a second. I'll mute myself.
Yeah, I'll start. Good morning, jury, fellow participants, and viewers. We are Team Avisa from Dr. Banman Nanavati College of Architecture, and we are very excited to present you Project Suparna. I am Shravani Joshi, team lead of 14% team, and joined with Gauri, Purva, and Neem. Yes, Neem. Uh, we are a team of architecture students, engineers, and we have been guided by outstanding faculty heads, industry partners, and project partners. Uh, uh, Next slide, please. Neil, your slide isn't changing. Can you? Yeah. Uh, the next one. Project Subarna is a housing proposal located in Ahmedabad. The site is in southern part of Gift City, which is located between Ahmedabad and Gandhinagar. Site is barren land and has views towards Sabarmati river from the west. Next, analyzing Ahmedabad's climate, it is hot and dry climate region, which is critical heat temperature, and the months which are critical are the March to June, and wind velocity of 2 meter per second is average throughout the year. So we understood this design intervention with appropriate climate, and we have tried to propose a solution for it. Next, particularly Ahmedabad has great potential of solar heat and renewability. And our site has the advantage of Sabarmati River, adding to the possible natural ventilation strategies for the future. And there are which adds to the great views as well. Our design is focused on maximizing these potentials to the fullest. Site is of 4,700 square meter area, which is surrounded by Gift City's development proposals, which is renewing throughout, and it is well connected with road network throughout. Site has the potential of surrounding future development in high rise, hence maintaining the privacy of the respective directions is under taken consideration throughout. Our goal is to design an innovative, sustainable structure for future of Ahmedabad cityscape with availability of resources, energy optimization, and material contribution. Uh, the specific project, uh, the dwellings were 3 BHK and 2 BHK throughout, uh, uh, which were proposed according to the need of the city and surrounding. Can you hear me?
Yes, yes. Okay, so talking about our goals, we basically aim to balance well-being of the user as well as harmony of the nature, and we aim to achieve sustainable and net zero multifamily housing in Ahmedabad, Gujarat. As Shravani mentioned earlier, it has hot and dry climatic conditions. So there are different ways which we are trying to tackle it to make that complete package of our multifamily housing as a sustainable proposal. So this is the list of interventions which we are trying to propose, like the scalability, affordability, resilience, etc. So to achieve these goals, what the strategies we were thinking about were evaporative cooling by vegetation, which will reduce the cooling load, or using locally available materials which can reduce the transportation cost, or using 5-star rating equipments which can reduce the energy load, using efficient water fixture which can reduce the wastage of water, and envelope optimization by using doubly glazed windows, efficient natural ventilation, then maximum intake of sunlight, etc. We are also planning to use photovoltaic panels which can generate up to 9,000 kilowatt of energy per day. And the base case EPI was a 64.56 in Gujarat, and we are trying to optimize it to 38.54. Next. So in this chart, what you can see is the materials which are generally used in buildings and what we are proposed to used in our buildings. So for example, doors which are generally of plywood or PVC, and we are proposing it to be of bamboo jute composite doors. So this will also reduce the material cost as well as provide occupation for the local vendors. And about the price income, we have divided the target group into two categories, which is mid income range and the high income range. So generally, the price income ratio in Gujarat is 10.6, and we are trying to make them affordable for all ranges. We have put a limit on the selling price of the dwelling units we are proposing up to 8, which is lesser than the price to income ratio of Gujarat. Next. So basically, talking about the form development, we have started with a vertical mass because it is a high-rise building. To get maximum intake of natural light, we have provided a courtyard and converted the block into a C shape. And the perpendicular fans, we have tilted it to 45-degree angle to give Sabarmati River view to each and every dwelling unit. Eventually, we came up with this Y-shaped plan. So the entire site unit includes open recreational spaces. The entire building is resting on a podium, and the space inside the podium is used for parking. We have sports area, swimming pool, water bodies, and other amenities as well in the building. And for earthquake resistance, we have used shear walls as a solution. Next. So these are our individual floor plates. We have two 3 BHK and two BHK flats on each floor plates. 3 BHK flats are 100 square meter and 2 BHK flats are of 80 square meters. And we have tried to place the rooms as per daytime used and the nighttime use according to the directions. So for example, the living spaces are towards the north, and the bedroom faces are towards the south, so we can avoid the harsh sunlight of south, and we can use the spaces in the night time. Next. Okay, so these are few interventions which we have proposed in the plan to adapt our housing units as per the COVID situation. So, for example, at the entrance we have wash and basin and storage space to keep things and sanitize it. Then we have movable partition walls, and we have separate working spaces to allow the people carry out their work from home peacefully. And same interventions have been proposed in 2 BHK housing unit as well. Next. Okay, so we have calculated the U value of different faces of the building, and we have tried to propose the configuration of materials to achieve that specific U value in the different regions as well as for the roof. Next. Okay, so talking about innovation, we have one major problem which we have to tackle. For that was, as I have mentioned earlier, we have opened the flanges so that every room can get the view of Sabarmati River. But at the same time, that those spaces are facing towards the southwest, so they are receiving maximum amount of harsh radiations of sun. So to avoid that, we have came up with two options. First was to provide windows which are of two layers. First is glazed, and the second one is lowered. and the balconies, and providing balconies there which can act as a buffer space for the radiation. As at the same time, we have provide sliding panels over the balcony, so that at different time, whatever angle the sun rays are coming, they can adjust it accordingly. As well as we have provided planters to keep that area cool and to reduce the radiations, also to make the air cool which is entering the unit. Next. This is our second proposal, was to create an entire opening with a composition of glazed as well as lower windows, and provide a shading device as a chhajja in the front part, and adding planters there, so the air which is entering will go through those, and it will reduce the temperature of the air. At the same time, the air which will rise due to stack effect, while leaving it again, it will pass through lowers and vegetation, and again it will cool down and then enter the atmosphere. Also, the chhaja has some perpendicular projection which can act as an obstacle for the sun rays falling on the wall. Next. So also we have tried to innovate the materials, use innovative materials. So first two are our top priorities, which are compressed stabilized earth blocks and agrocrete blocks, which are natural materials, eco-friendly materials, and we can achieve U value using this material. And our second alternative is hollow core concrete blocks. So we are giving priority to the first two materials at initially. Next. So, as I have told you, we have two options. We have finalized one out of them. That is using two windows of two leaves, which we first layer will have louvers and second layer will have glazed panels sliding. So we have tried to work out the details to make that proprietary system, so that we can repeat it throughout the structure. So these are the working drawings for them. Next. Uh, Shravani?
The health and well-being of the area is maintained through the thermal comfort. Main idea was to utilize the maximum natural ventilation and provisions that we can. Also, it to optimize the window window operations, and try to create a natural system for the building. Next. The reduction of the thermal stress and outdoors is done by the creating podium spaces and the visual comfort throughout the building, to connect to the outdoors of it, which is lacking in Ahmedabad as a space. Next. Yeah.
Yes. Uh, the reliance on passive strategies is important not only for today but also for the future. So the optimization was done from top to bottom process, from massing to shading. Each step looked at different parameters as inputs and outputs to reduce the heat gain, reduce the heat gain, maximize the views, and accommodate other requirements through the year. Envelope optimization ensures enhanced light and ventilation in the house's post occupancy. The U value of the walls and roof was decided through analysis of possible combination and its impact on cooling and the energy use. Yes. The windows have been enlarged to ensure natural ventilation and at the same time allowing sufficient daylight to at the same time. The openings were divided into three panels that allow the possibility of having only ventilation, only lighting, or both lighting and ventilation due to the lowered windows and the movable jalis provided. This composite combination of windows and openings provided UV resistivity and extended lifespan. On the unit level, the size ratio of the openings and rooms was such that it ensured maximum daylight penetration in terms of depth and boat time. Daylight analysis was done for ground floor units due to lack of sunlight. Exposure due to mutual shading strategy for the proposed window design. Two cases were studied. one with shutters closed. The indoor operative temperature was recorded to be 32.8 degrees Celsius, which falls under 90% of acceptability comfort band as calculated from IMAX standards. For the case 2, the shutters with for the case 2 was shutters open. Operative temperature was recorded to be 33.5 degrees Celsius, which is again under 90% acceptability of thermal comfort band of the same standard. The next slide, please. The three major goals of our project were to achieve net zero energy, net zero water, and net zero waste. The reduced EPI was met through passive measures like optimizing massing, shading devices, and installation. Further reduction was achieved through strategies that ensured use of low energy lighting equipments and comfort systems, leading to a total reduction of 59% from the base case. Next. Next slide. Yeah. Next slide, please. For the water performance, the base case scenario was established considering various water consumption activities, efficient low flow fixtures, behavioral measures, and wastewater recycling were various measures used to reduce the fresh water demand. Total of 70% of water saving can be accounted for the use of grey water. I will hand over the presentation further to my teammate Neil to continue from here.
Yes. Affordability. Our goal is to reduce the cost of unit and create an affordable luxury, and by constructing a multifamily housing which is affordable for larger section of market without compromising the comfort and convenience of the residents. So the strategies were applied for the affordability are the energy efficient solutions to reduce the energy consumption by and achieving 75% of floor space lit by daylight, reducing the expenditure of artificial sources of lighting with lower utility cost. Excellent natural sources, excellent natural cross ventilation through windows, jalis, and shadings optimization reduces the expenses of mechanical ventilation system. Evaporated cooling by vegetation, reducing the cooling load. Use of photovoltaic panels. Use of local available material and material choice in order to reduce the transportation cost being locally sourced and construction cost by using locally labor force, and ACC blocks used for fast construction that in turn gives faster possession and more returns. The strategy of switching the materials which are sustainable and all as well as cost efficient with easy maintenance being locally sourced. Use of equipment with 5-star rating, reducing the energy loads, and they are energy efficient solutions. Water saving and use of water fixtures. And the last one, energy optimizations, double glass windows, efficient lighting and equipment, and shared VRF system reduce the base case of EPI of 64.56 kilowatt hour per meter square per year to achieve the target of EPI 38.58 kilowatt hour per meter square per year. Scalability is a similar concept climatic zone. High-rise building that can be replicable to any similar context with less water, hot and dry climate. The aim was to create the tower that would meet the needs of the middle income groups people at the same the layouts are. So flexible to be adapted according to the pandemic solution. Also flexible accommodation that can be adapted to changing needs and occupant numbers. The flexibility of planning according to the pandemic requirements as well as innovative facade design make it appealing in today's market. The approach module is such design that it tackles the issues of water storage, comfortable micro conditions, uh, high temperature fluctuations, and using the sun radiation to generate electricity. the market potential. Since Ahmedabad is the India's first World Heritage City and country's third most livable city, population growth in the AMC limits is exceeded to be 15% by 2030, necessitating compact and efficient real estate. With the increasing growth of the population and urbanization, demand for residential and commercial space will expand, but because urban land is scarce and expensive, smart development will be required and vertical expansion will be critical for the city. Uh, yeah. Communication. A net zero multi-family housing project is a relatively less explored area in the building industry. The net zero energy and water design are even more so. The design process was developed with the data-driven integrated design approach by the multidisciplinary team from the building science, architecture, and engineering disciplines, along with the technical support of industry partners. Our team members also contributed in river cleaning in Pune on 20th December with the organization called Pune Bloggers. Also, the lecture was conducted on 25th of February by our fellow student to spread the awareness of the sustainability. Yeah, and also the creating an Instagram account was one of our communication source to reach more people. So this is the video of our project.
Five minutes remaining.
Thank you for your patience. We are done with our presentation. We can move forward for the discussion.
That's great, team. You guys were, really well on time. So now maybe let's take comments from the jury. So yeah. So Dheeraj, you want to go first?
Sorry, I was on mute. Maybe I'll allow others to go first, and then maybe I will just come in and pitch in later, if that is okay.
Yeah, sure. Jiten.
Thank you.
Yeah, good work. And one question I had was, can you explain the chart for climate? The first or second slide that you had. Can one of you explain? Go ahead. Yeah, this one. Just explain one chart. Have you understood it?
Yeah, the charts represent the temperature variations throughout the years.
Yes.
The second chart, actually, the one which is below, it is explaining how much amount of sunlight we receive
Yes.
each day throughout the year. So on the x-axis they have mentioned the months, and on the y-axis they have mentioned the amount of hours, and then they have showed the bars explaining how many sun hours we receive every month in an average.
In an average. Okay. So, can one of you tell me what is direct normal and what is direct horizontal? Actually, I can't read it, but there is global horizontal and there is direct normal. What is the difference between the two? That is for hourly average, daily towers only. And what is the orange one? What does it indicate? This is just to understand whether you understood the charts or not. What is direct normal? What is global horizontal? What is total surface? It's okay if you don't know. It's fine. But if one of you knows, then can please explain.
I know the direct normal. They are the concept is called perpendicularly to the area. So those
Very
rays are
good.
normal rays.
Very good. And you know about the other ones also, the green global and the orange surface radiation. Okay, no problem. Huh? In health and well-being, can you go to that slide? Health and well-being. Yeah. Can you explain this first chart, direct sun hours? What is happening?
Sorry, sir. Can you repeat it?
The first chart, that is that chart showing the blues and yellows. Can you explain that? What is it showing?
I have simulated it in Rhino in Ladybug. So there is index on the right hand side, yellow to blue. Those shows they have formulated a grid on the entire plan, and the color shows in an average in summer months. I have taken it from April to till June. So in that peak summer summer months, each grid shows a color which annotates the number of sun hours which is falling in that region. So if it shows some let us say it's 563 hours, so annually that region receives that much hours of direct sunlight, that specific pixelet on that plan.
Okay, so this is for the whole year you have done.
No, sorry, for the summer months from April to June. So it's an
For
average
summer
of
months.
yes.
Okay, fine, huh? Otherwise, I don't have any questions. You, in API calculation, sorry, just one more. In envelope optimization, can you go there? Envelope optimization, in which it was where you showed that your EPI is going down from something like 68 to 38. So it was simulation, I think. That chart. Baseline to proposed. EPI calculations you had done. Yeah, this one. So this also you did in Rhino. Which software did you use this?
No, the simulations were done in Design Builder. So Design Builder, this was a graph that was obtained after doing the simulations in Design Builder. So these were the values that we got uh, after simulating the base case with the like proposals for like first optimized massing. So if optimized massing was used, then it was reduced by around reduced to around 61%. So again, then when shading was added, then again it how the graph, like after adding various proposals and combinations, how the EPI was got down to 38.5, that is
Okay.
59% of the total
Very good.
deduction.
Fine. So I'm I've completed my questions. Otherwise, it's a good job you've done. So congratulations to all of you. Amit, you.
Samit, you want to go next?
Yeah. Team, thanks for putting the effort. I know it's been very difficult. Coordinating between 14 people to pull off something like this is very, very difficult. So I just want to congratulate you on this effort. I don't want to ask a question, but I'll just, I mean, we've already given our comments, so I'm sure you've gone through them. Just want to highlight a few things. I mean, the beauty or the challenge in these kind of projects is that it forces you to look at the interplay between different systems. You cannot just look at one and finish off a project. So I think that's the real learning from this kind of an event. This is just not an event; actually, it's a learning experience. I think that's the real learning here. So I missed the engineering in this entire part. I think you've gotten the elements everywhere. I know there are a few inconsistencies throughout the report. We pointed that out, so I don't want to go through it again. But I miss the engineering genuinely, and it's something which, like I said, it's like having a body without a soul. No, I'm the engineer, so I prefer to think of it like that. So you need to have both, and I think that's what I miss. But you've come so far. You've got all the elements in. A little bit of effort and focus, and I think then you'll be on your way. Thank you for putting this effort.
Thank you, sir.
Dheeraj,
Yes, Srijit.
you want to add your comments in?
Srijit, can I put in a few words?
Sure. Yeah.
Thank you. Thank you, ladies on the call, and appreciate the work which you have gone through. I particularly like the efforts you all have put on the innovation side. Real efforts and something different, something more than the usual is how I look at it. Something which I liked, which I wanted to put it first. Okay, and as Samit also pointed out, not easy during these tough times to collaborate and work together for sure. And coming out with your ideas and thoughts was a good effort. Just a couple of questions which I had also put in my comments, and I'll be a little anxious to see if you have been able to spend some time on that. I know it's your curriculum also, which you have to take care of, and studies as well. On the electrical side, I saw that while individually you have picked up the equipments and seen that how do you reduce the consumption of all these equipment, picking up the five-star labeled products, etc. But I could not see the linkage between the overall energy consumption to the solar generation and how do you tend to reach towards a net zero with that effort. So were you able to spend some time on this? Did you look at that question? Is one of the questions which I had. Anybody can go in for that. No worries. If you're not been able to spend time on this, that's okay. No worries. I understand. As I say that, studies are equally important and you will have to balance your time between these two things. Nonetheless, other than that, my only question was I had also commented about the fire eventuality and that I did not see captured in your report on the resilience side. Were you able to focus on that as well?
Please, could you repeat? Actually,
You're on mute, Purva. You're on mute.
there's a network issue from my side. I can't hear you actually. Can you repeat the question, sir?
I'm saying that on the resilience
Hello.
side, I had commented about fire safety to be taken care of. Could you go through that comment and could you work around it as well?
Uh, we have actually worked on the resilience of the structure, but somehow we were not able to put it in the final presentations. So, so
No
Yeah,
worries.
we
That's okay.
haven't been able
That's
to
okay.
put it in the final presentation. So.
No worries. As I say, there is always a learning curve. You should not worry about it. Pick up those things which you might have missed, as Jitain also pointed out a couple of things. And suggestion for you, Shravani, am I saying that name right?
Yes, sir.
She- Okay.
Yes, sir. Yeah,
Shravani,
that is
I
correct.
saw a lot of energy when you opened up your discussions on the slides. You got the capability to present. You just modulate your speed. You need not hurry about it. Time is essential, I know. But if you modulate your speed, you'll be able to express yourself better. And second, for all of you, is when you have 25 minutes to present. I mean, I'm just giving you a corporate thought, the way we work and the way we operate is you need to spend about 2 minutes per slide to express yourself as best as possible, efficiently and effectively. So if you condense your presentation in such a way that you manage 2 minutes per slide, whatever time duration you have, I assure you, with modulating your speed, you'll be able to do excellent work on whatever you want to present. So work around these areas. I think you as a team have done a great job, and all the best to you. Do well. Thank you. Srijit, that's all from my side.
Thanks, Dheeraj. Thanks, all the jury members. Thanks, Team Avisa, for this good presentation. You got your comments from the jury. Hope that was really helpful for you guys. So let's now just take a 5 minute break and we'll go into the next presentation in 5 minutes.
Thank you, sir. Thank you.
Thank you,
Thank you
jury.
for your comments. It was really
Thank
helpful.
you.
Pleasure.
And we're back for our next presentation. So the next presentation is from Team C Negative, and they have worked on a project called Project Akian in Pune, Maharashtra. The project partner is Namrata Group. So can we do a quick AV check for our presenters? Priyanshi, are you here?
Yes, I'm here. So,
Yeah,
just a doubt: is this
yeah.
streaming or is it just it's just a check, right?
This is streamed right now. Yeah.
Oh,
Nishna, you want to go next? Can you do a quick AV check?
Hello? Yes.
Yes. Yeah.
Am I audible?
Uh,
Yes.
yes, you're audible. Sakshi?
Hi. Yes.
Yeah, great. Anusha?
Hello.
Yeah, can hear you loud and clear. So can we get your screen shared, and can you go into the presentation mode?
yes. So the screen is shared by the backup presenter, and he has started sharing the screen.
We don't. Yeah. Okay. Right. All right. Okay. So team, you will have 25 minutes to present your work to the jury members. At 20 minutes, you will hear a ring like this from me. You heard that?
Yes.
Uh, so this means that at 25 minutes, I will need to stop you, and you won't get a 26th minute to uh, do your presentation. And after that, this will get followed by a 15-minute Q&A session. So try to keep your answers direct. Try to keep your answers succinct as much as possible. So yeah, the stage is yours. All the best.
Thank you so much, Srijit. Good afternoon, everyone. We are Team C Negative from D.Y. Patil School of Architecture, Pune, and we are extremely elated to present to you Project Akhyan, implying the beginning of a new story. I am Priyanshi Garg, the team lead of our 11-person team, and I'm accompanied by Sakshi, Anusha, Nishna, and Shaunak. We are a team of 11 undergraduate students of architecture and engineering, bringing diverse qualities on the table. We have been guided by the exceptional project partners, industry partners, and faculty guides. Akhyan is a multifamily housing project designed with the purpose of build, own, lease to the occupants. It is located in Talegaon region of Pune district, which is considered as an economical residential destination of the city. The area of the plot is 1.35 hectares and the proposed design comprises a total of 371 tenements.
When an individual is investing in a dwelling unit, they consider future prospects as well. To provide a future-proof housing solution, we have attempted to provide a community-like space along with factors such as roof gardens and hydroponic jalis, which will influence the microclimate. Thermal influence to maintain thermal comfort throughout the year, leading to reduced energy consumption and bills. Using water-saving fixtures and EV bike stations will raise awareness among the people and the sustainable lifestyle. Other innovative features such as patent tiles will instill a sense of affordable luxury, and that's how we aim to cater to the middle income group through our architectural design and its allied features. Since Pune experiences a warm and humid climate, we studied in detail about what design interventions would be appropriate for this design of climate. Pune, in particular, has a very high potential for passive cooling owing to the possibility of adequate natural ventilation. So, all our major design interventions focus on optimizing this potential. The psychrometric chart justifies May as the critical month with the highest temperatures and humidity levels. Various passive strategies such as internal and external shading devices,
wall insulation, and appropriate glass materials for windows have been deployed to maintain comfort. Talegaon, located in the middle of Pune-Mumbai-Nasik triangle, has great connectivity with NH4, which brings offices hubs like Hinjewadi and Baner close to it and provides excellent quality of life. The site is surrounded by yet another housing complex on the northwest and by lush greenery and low-lying hills on the eastern side. Since it is a multi-family residential project, the hours of operation will be 24 hours throughout the year.
As per the analysis of the site, Talegaon is developing rapidly as it is well connected to major cities with low property rates. There has been an increase in pollution levels due to population growth. An inadequate and improper stormwater drainage has posed to be a weakness of the site. Our project has taken shape by inculcating these factors as well. We came up with multiple options that were evaluated for functionality, adaptability, and energy comfort. Starting with the block massing, the building is oriented with a longer facade along the north south direction to minimize solar heat gain. The mass was further split as per the prevailing wind direction to provide cross ventilation. Three floor plates were planned as decided by the project partner. A central service core was planned for easy accessibility. Due to the peculiar nature of the site, various floor plate combinations with maximum openings in north-south directions were tried out before we finalized our site plan according to the climate analysis. The site plan was finalized considering the open recreational space and smooth site circulation. The main entrance and exit of the site is from the west end. The buildings A and D consist of 28 2 BHK large and 28 3 BHK units going up to 14 floors. The buildings B, C, E, and F consist of 28 2 BHK large and 28 2 BHK compact units going up to 14 floors. The building G consists of 35 1 BHK units going up to 16 floors. The parking is accommodated along the south side boundary and on the stilt to avoid basement construction costs. There's also a provision for an EV charging station on site to promote sustainability. The membrane bioreactor sewage treatment plant is provided towards the east end of the site, away from the building blocks, preventing foul smell.
According to shade and shadow analysis, the master plan allows maximum wind flow and cross ventilation. The buildings are placed in such a way that open spaces and green spaces are shaded by surrounding buildings to maintain the microclimate. A central open space provides a sense of united community with families. Facades exposed to west bear insulated wall to reduce heat gain. Shadow-free solar PV panels, vertical axis wind turbines, and gardens are provided on the roof. Terraces, balconies, and windows provided on the south side will provide views of the hills. Since this is the family housing scheme, we have designed a clear distinction in terms of vehicular and pedestrian circulation to ensure the efficiency and safety of the site. Vehicular circulation is provided as per the stilt floor accessibility, and pedestrian circulation is restricted to the pathway surrounding the central green space.
A 1 BHK dwelling unit consists of a living room with an attached terrace to let in sufficient amounts of sunlight and avoid any usage of the mechanical lighting equipment during sunlight hours. Alternate terraces are provided for a sense of larger space. A 2 BHK compact dwelling unit has spaces oriented in such a way that both the bedrooms achieve maximum occupant comfort considering the wind flow direction and sunlight. We can also observe an alternate terracing system in this unit. A 2 BHK large dwelling unit is comparatively a bigger apartment with a balcony attached to the living room and the master bedroom. It allows for maximum light and cross ventilation inside the whole apartment, maximizing the occupant comfort.
A 3 BHK dwelling unit is optimized by providing openings so as to maximize the use of daylight. Also, the arrow shows that it has been eccentric cross ventilation. The terraces are again arranged in an alternative manner and the guest bedroom is segregated for more privacy. Moving on to the floor plate planning, Building G consists of 5 1 BHK dwelling units on one floor, making a total of 35 units in the building. Central light well is provided for light and stack ventilation. Building B, C, E, and F with the same floor plate consist of 2 BHK compact and 2 BHK large apartments on one floor. Exterior ducts are provided on the shorter ends of the floor plate.
Building A-D with the same floor plate consists of 2 BHK large and 3 BHK apartments on one floor. Along with light wells providing stack ventilation, exterior ducts are provided on the shorter ends of the floor plate. Sustainability is achieved through climate responsive design, energy generation, and reduced energy consumption. Innovative parameters are integrated with architectural approach, and a resilient self-sustained housing is proposed. Comfort and well-being of the occupants is of primary concern. This was ensured by firstly providing proper natural ventilation and lighting through the buildings. Then passive design measures were adopted. The graph shows the thermal comfort range throughout the year laying within the comfort operative range.
Moving on to visual comfort, we have used double pane low emissive glass with 0.75 visual light transmission, avoiding any harsh light. We have used overhangs to prevent direct glare. Various window to wall ratios were simulated, and the best suited window sizes were extracted for each room facing different directions. The WWR ranged from 10 to 30%. Low emissive glass having lower SHGC also helps in maintaining thermal comfort. Our goal to restrict the energy consumption of the building was to generate energy on site by using passive design features and energy efficient equipments. For energy performance, we have evaluated occupancy charts as per the usage of equipment, lighting, and HVAC varying in summer and winter. These were evaluated on a preliminary basis before we reached the conclusion of not providing HVAC equipment for our building. HVAC load will in turn increase the amount of energy being consumed by the occupants. The EUI, energy use, and energy balance graphs shows the equipment and light usage with no HVAC provided to reduce energy usage and in return reduce maintenance cost. Hence, achieved EPI is 14.5 kilowatt hour per square meter per year. For energy generation, solar PV panels and vertical axis wind turbines are provided on rooftops. Solar panels provided over parking generate electricity of about 65,400 kilowatt hour annually. The flowchart shows the energy flow to the building programs from energy generating sources. In case of excess energy, it can be directed to the grid, forming a smart grid connection.
Passive design methods like providing a maximum of 100 mm thermal insulation as per ECDC using XPS extruded polystyrene, air gap, and mineral wool are used to reduce heat gain in summers and heat loss in winters. Using paints with high reflective index and low emissivity glazing will further help in maintaining internal temperature as per comfort range. Energy saving equipment with higher BEE ratings will yield lower operating costs. To attain an integrated net zero water cycle, the first question that arises is how to reduce per capita per day water consumption. We achieve this by using water saving fixtures such as Bitra's water closet that reduces the flow by 50%. Earth focused fixtures are implanted to lavatory and kitchen faucets, which further reduce the water consumption by 96%. A spray type eco shower fixture is used with a shower head to reduce the flow by 85%. The net reduction in water consumption stands up to 84%, which means that water consumption significantly reduces from baseline 135 liters per day to 21.5 liters per day. The second question that also leads to the next stage of the cycle is how do we treat the maximum amount of consumed water on site? A membrane bioreactor is a sewage treatment plant that ultrafilters water with a biological process, thus producing high quality effluent. Hence, the grey and black wastewater produced on site is treated with an efficiency of 75%.
Mean annual rainfall of Pune is 1018 mm. Due to high rainfall in the region, the rainwater harvesting system has an increased potential in the project. Surface runoff from various rainwater harvesting surfaces such as roof surfaces, hardscape, and softscape areas is taken into account. This has helped us meet 48% of the water demand on site. The site plan highlights different categories of potable rainwater catchment areas, first being roof surfaces. The second category highlights the hardscape catchment areas possessing the maximum ability for rainwater harvesting.
The third and the last category highlights the softscape catchment areas. This will have a minimal effect due to a low runoff coefficient. According to the climate report of Pune, it experiences an average of 314 dry days in a year. This leads us to another question. How do we plan on meeting water demand when there is no rainfall? This has been effectively achieved by designing the storage tanks of adequate capacities for storing the rainwater. The rainwater is first collected during the rainy days. The excess water which lies beyond the water demand is then stored for later use in the rainwater tanks, which is filtered and then utilized during the dry months. This shows the locations of rainwater storage tanks on site. Storage tanks receiving rainwater from different surfaces are indicated in different colors.
Talegaon is a flood-prone area which acts as a source of groundwater recharge. This further helps in restoring the groundwater table as it is considered to be the major source of drinking water in that region. Groundwater is thus recharged on-site through bioswales and percolation pits. The flowchart shows the integrated net zero water cycle achieved. Water for consumption is received on site through the groundwater. The water stored in the underground tank is then filtered and transferred to the overhead water tank and first few floors using a solar water pump. The floors above receive water from the overhead tank. The grey water coming from showers, laundry water, bath water, and lavatory water is then treated in the membrane bioreactor. The treated water is utilized in landscaping and certain domestic purposes such as car wash. The black water collected is also treated in this plant. It is then utilized in the flush tanks and some part of it is returned to the earth. Connection to the solar water heater is made to lavatory faucets. Harvested rainwater further helps in groundwater recharge, thus completing the cycle. The groundwater is also recharged while flooding through bioswales and percolation pits. Hence, we successfully achieved a net zero water cycle. In fact, there's also a small amount of 20 kiloliters net water saved annually.
Our target is the middle income group for this project attracted to this location, such as biotechnologists, students, industry workers, etc. Project Akhyan is a sustainable alternative to multifamily housing in a rapidly developing area. Due to COVID-19 pandemic and the new work from home culture, an unforeseen gloom has been casting, affecting the mental health of the people trapped indoors. The design of such a space revolves around combating this isolation with nature and community space for the residents to gather and interact, including features like solar streetlights and EV bikes. Considering the constructability at scale aspect, AAC blocks have low embodied energy per square meter, which results in reduction of greenhouse gas emission, making it a sustainable concrete alternative. Paved tiles convert the kinetic energy generated by pedestrian movement to electrical energy. Such an advancement in technology ensures team integration of construction knowledge during the design phase. Reviewing the construction waste management with the labor saves money and further serves to achieve adequate design goals. Apart from saving capital investment of about 20%, we were also able to reduce operating costs of building systems. Certain features such as hydroponic jollies and paved tiles pose a higher capex than the opex.
As the project has not been initiated on site, we have estimated the timeline of 3.5 years within which the project will be ready to lease. Certain project-specific scale-up features include availability of vacant land around the site for future expansion, rapidly increasing population in the area due to industrialization, improved air quality as compared to the Pune or Mumbai cities due to the less traffic and sustainable design. The large-scale implementation falls under three principal rules of project scope, time management, and cost efficiency. Stability of the water system is important to provide post-disaster to support community resilience. We have landscaped our site in such a way that water is percolated via grass swales and percolation pits. Bioswales are provided along the periphery of open space covering an area of 450 square meters along with permeable softscape of 1700 square meters resulting in flood resilience of 2150 square meters.
Resilience from heat waves in Pune city has been a priority for a long time now. In order to deal with heat waves, windows with adequate WWR and shading devices are proposed with wall insulation and movable shutter and curtains in windows. To tackle earthquakes, we have provided reinforcement of soft stories with shear walls and thereafter the offsets in structural designs are reduced to minimum. Appropriate measures against safety have been adopted. By using solar PV panels, we are creating alternate source of electricity during a power cut. It will supply electricity during power disruption through a hybrid grid connected solar system with battery storage. Wet and dry waste is collected from door to door. It is then segregated and disposed through third parties safely with organic waste used as compost. We have briefly shown the site operations in terms of electricity and waste management. The electricity is supplied from Maharashtra State Electricity Board to the transformer room, which is then converted to required wattage and supplied to electrical rooms of the buildings and to street lights when they are not charged by solar panels. For solid waste management, the waste from respective buildings is directed to septic tanks and then to the MBR sewage treatment plant. The treated grey and black water is then reused for landscaping and recharging groundwater respectively. Innovative features incorporated within our project were hydroponic facades, EV bike stations, solar panels over parking and street lights, and pavement tiles.
Hydroponic facade is provided to conceal the exterior ducts and helps in cleaning up air pollutants and absorbing sound from the surroundings. It also acts as a heat barrier to reduce heat gain from east and west directions. Solar panels provided above parking space will act as a shading devices and will generate energy at the same time. EV system reduces dependency on fossil fuels, produces no emissions, is beneficial for overall health and makes use of solar power to discharge the cycles. Pageant tiles made from nearly 100% recycled materials generate energy when compressed. Lastly, we have our nil bill application, which serves our aim of making end users conscious about their actions. This app is just a prototype of our idea which revolves around making the consumer more aware about their electricity and water consumption, along with providing some incentives like redeemable reward points. Reward points would be credited for saving more energy and according to steps walked monthly. The app will also educate the consumer about the guidelines laid by ECBC or GRIHA and if their consumption is in compliance with the same.
We were successfully able to communicate and exchange our ideas through our Instagram handle and YouTube page, and we have witnessed a massive growth of audience within the last 2 months on these platforms. We have also acquainted our peers about the competition aims and goals and displayed our work for the better understanding of the cause. Project Arkan will benefit in terms of sustainability and cost. Sustainability has to be a way of life to be a way of business, and our project aligns with these natural forces rather than defying them. Thank you.
Wow, nice, interesting presentation and on time as well. So I think, can we take the jury comments? Samit, can we go with you first?
Yeah, thanks. Thanks, team. It's excellent presentation. Very, very nice going through it. Very pleasant. And
Thank
actually,
you, sir.
I like these You have a tagline under your project name, your story, our story. I don't know if it's the developer's tagline or yours, but it was a great tagline. Is it yours
So,
or is it the
yes,
developer's
sir.
tagline?
No, so we came up with it.
Awesome, awesome. I love the tagline. I think
Thank
the
you, sir.
presentation was excellent. I mean, really very crisp, and I can see that you've taken the comments you've given and you pushed them into the presentation, and that's really heartening for me. It's impossible for this is a big project. Pulling this off, getting this to net zero is not at all easy. But the effort you've put in, and the fact that you've taken feedback, and that's really heartening to me. And I really want to congratulate you on that. I can see a lot of areas where at least my personal comments have come into the presentations, and I want to thank you for that. Just a small word of advice. I mean, this is difficult. I know it's difficult in real world, in actual practice, to pull off a net zero building. But we will have ideas coming up during the development, uh, and my advice would be to see as you get into your practice, as you sort of get into your career, to take a drive an idea through to the end. That's the real important thing, because concepts are there, ideas will be there. It only works when you have figured out how to put it into the project. So I mean, you're all going to be in the space of making things work, right? I mean, you have to be you're not only going to sort of make a concept presentation, you're going to be building them. So take your ideas through, drive it through to the end of it, and then I think it'll help you calibrate some of these ideas which are coming up. But that's it's part of learning, and it's part of the experience, and that's something which I would like all of you to sort of focus and work on. Otherwise, thank you for an excellent presentation. Really lovely. Thank you.
Thank you so much, sir.
Jiten, are you there? And do you want to go next? Could you turn on your video as well?
Yeah.
Great.
So very well presented and very concise. Team, congratulations. Uh,
Thank you, sir.
this is something that I've always been, curious about. But can you explain a bioswale and how it works? Any one of you?
So the wastewater, it gets into the system after passing through septic tanks. First, it passes through septic tanks and gets partially filtered. Then, basically, a bioswale, it has a semi. Okay, sorry. I was actually explaining membrane bioreactor. Sorry, sir. I got confused.
It's okay.
Do you want
A lot
to
of people might be
show your
curious
slides
about
as
it.
well?
Yeah.
Would you
Sir,
like to
so
show your
bio,
slides as well?
yes, yes.
Yeah.
Yes, sir. So actually, sir, biospheres is the system which can be implemented near the pathways and where the roads are meeting. So, sir, in this system, the water gets treated and then it returns to the ground with the help of materials like geotextile and aggregates. So it gets partially filtered so as to it can go back to the ground. So basically, the toxicity level of the water can decrease through that.
Okay. So can you tell me why a drain tube is also given? There is a geotextile stormwater drain, and then there is flows into a drain tube.
Sir, so the materials which are remaining behind, the materials which are remaining behind, and the water which is not percolated into the ground can be disposed of via the drain tubes.
Okay. Uh, your nil bill application is very innovative, very nice. And
Thank you, sir.
one question I had regarding your EPI calculations is that you have not considered HVAC at all. Yeah, this is like very for your yeah. So this is very good. Uh, for your EPI calculations, you have not considered air conditioning of any sort, and I just wanted to understand a little bit more.
So, sir, for the target API, we considered air conditioners, but after our project, we did the thermal comfort analysis and everything. We realized that HVAC was not required. So that is another reason why we were able to achieve the EPI of 14.5.
So HVAC is not required by.
So, because throughout the first of all, we have provided the thermal insulation on southern and western walls of a maximum of 100 mm, and on eastern and northern walls we have provided insulation, but not 100 mm. So we are able to reduce the heat gain via thermal insulation, and then using hydroponic jalis, we are influencing the microclimate. So we are maintaining the thermal comfort temperature, and also with the cross ventilation. So we did this analysis in which we found that we did the analysis of each and every room of each and every apartment and building, and then we found that the indoor operative temperature lies within the comfort range throughout the year. So with that, we reached to the conclusion that ACs will not be required.
Very good. Okay, I'm done, Srijit.
Dheeraj, you want to go next? Your comments?
Wow, is all I have to say. Okay, and not being repetitive, Samit, may I borrow everything what you said? And uh, amazing work is what I will say. Comprehensive work. And the question which Jiten asked was the only question which I had with me with respect to air conditioning. That being the trade I come from, so that was also my observation as well. So certainly you have taken care of all the aspects to come to the conclusion that you can manage without HVAC. I understand that through the heat loads. A very brave step, let me tell you, under the current environmental conditions, a very brave step. And since the detailing is done, so I will not push you hard on that. The only thing in your report which comes to my mind as a suggestion, okay, nothing to tell you that you have not done this. On communication, if you connect your target segments to the medium which you are restricting yourself to as Instagram, will it be reaching out to your target audience is the question you must put to yourself and see what more can be done, what additionally can be done to reach out to your target segments. Insta is a very popular social media today. I know my daughter uses it too.
Yes.
But then, is it the right medium for this target segment? Is the question we must ask ourselves. That's all from my side. And thank you and appreciate the work which you all have done. And all the best.
Thank you. Thank you so much, everyone. Thank you, sir.
Thank you.
Wow, wow. Great comments from our jury members, and great presentation, Team C negative.
Thank you, Shruti.
So we'll move on to our next presentation. Meanwhile, thanks, Team C negative. You can move out of the studio now.
Thank you.
Yeah. So we'll take 5 minutes and move on to our next presentation.
Sure, Sid.
So we're moving on to our third presentation today, and the next presentation is from Team Inferno. They have worked on a project named Savvy Studios in Mumbai, Maharashtra. Their project partner is Harasid Projects. So can we do a quick AV check with our presenters? Hi, Ash. Can you say something? And
Hello. Can you guys hear me?
yes, great.
Yeah.
Loud and clear. Hi, Soumya. Could you go next?
Yeah. Hello.
Yeah.
Am I audible?
Raj.
Yeah.
Hello.
Yeah, great. And Riddhat, is it? If I'm pronouncing it right?
Yes, it's correct.
Yeah.
Is
So
the light okay?
yeah, that's all right. We could center yourself to the screen a little. Riddhat, we don't seem to be. Yeah, that's great. That's good. Okay. So can we have the slide share? Can you start sharing your slides and go into presentation mode?
Just one second.
Yeah.
Okay.
All right. So I think we can see.
Just one second.
Yeah. Just go into presentation mode. All right. Okay. So team, you have 25 minutes for your presentation, and at 20 minutes, I'll ring a bell like this. You could hear that, right? Yeah. So you won't have a 26th minute, which means that at 25 minutes, I'll need to stop you and I'll need to ask you to end your presentation. After that, this will be followed by a 15-minute Q&A session. And so you need to keep your answers direct to the point and as succinct as possible. So all right. So the stage is yours, team. All the best.
Yeah. So just a second. Let me there's some problem with my slide. Just a second. Let me reshare it.
Yeah.
Can you see, sir? Just one second.
It's not yet coming up here. Yeah.
Just one second. Huh? Yeah.
All right. All the best. You guys can start.
Thank you.
Can you guys see the screen?
It's loading.
Yes.
Okay. Hey jurors, Team Inferno here. So we have, including me, we have three other presenters: Arsh, Soumya, Raj, and Riddharth. So starting with our project,
Our partners include Harsid. developer.
Yeah. So we are working on a redeveloping project like a multi-family housing in a sustainable way in Mumbai is a challenge due to high density and priority on profitability. So the multidisciplinary team from Balwant State University has partnered with the Harshad Group to redevelop a 3,100 square meter residential complex in Kandivali of 147 tenements.
So the main project highlights are as follows. There are 9 different topics which we have tackled with to come to the current design of the project. Starting with energy, we've looked at a lot of shading devices. Coming to resilience, to manage the disaster, we have looked into various aspects which we will talk about later. Then we have innovation, coming to net water, cost efficiency, waste management, architectural design, scalability, and engineering, which will be done in phase construction. Next. So the site which we are working on is Kandivali West, which is one of the most growing and upcoming suburbs, as it has a lack of quality spaces and has a rising potential for the supply of residential real estate. Next. So, Kandivali, the reason why it's one of the most developing localities is because it has great connectivity to Link Road and Western Express Highway and good infrastructure facilities such as commercial complexes, schools, colleges, and hence attracting a range of tenants from single working occupants to expanding families. These are the little percentages of the working class of retired people, officers, and government employees. Um, to provide adaptable and flexible housing layout with optimized FSI consumption was our main saleable component. And we also wanted to maximize the use of common areas with efficient FSI usage. Next.
So coming to the market potential of Kandivali, how there were different challenges. Like we had to understand the market potential flats in Kandivali West. Then how design and replicability will work in the particular market in Kandivali. How much scalability and modular buildings we should make, and there were a lot of key factors. Even like making the internal layout flexible and different type for different type of people. And the main key factors were amenities, location, economic boom, connectivity, and market. We also wanted to make the design interactive and self-reliant. So since the price range in the Kandivali was quite high, so since we were focusing on working class people, we tried to lower down our the selling price, and we down to cut down the price and make it more affordable. So yeah. And coming to the goals and strategies, the goals and the strategies for various contests are as follows. These have helped us in solving issues in innovative and creative ways, and made us like reach our final design. Coming in, starting from the architectural design, how we have used different layout optimize and available or use of proper FSI, decrease in radiation, self shading, and flexible planning. So on the left hand side there are goals, and the right hand side are the keys which we have how we have used to solve it. So coming to the water management, how rainwater harvesting, sewage treatment, reuse of treated water, net cycle, how we have created a net positive water cycle, how recharge of the groundwater is done, and selling of the saved water is be taking on the side. So coming to the scalability and market potential increase in sizes of the particular flat. Since we are giving back to the redevelopment people, we need like 40% extra FSI. So according to that, we had to design. Then including that, we had to make it affordable. So how we should like how we met the growing demands in the particular area, and like in the region with the redevelopment people. Then fenestration orientation and different forms have worked with us for the market scalability and market potential. Coming to the energy performance, how we have achieved like the final design have achieved an EPI of 23.1 kilowatt hour per square meter annually. And that is because of the on-site energy generation, passive design strategies, HVAC system, and how the orientation of the building in such form that there is no, like there is zero negative wind pressure, and then energy efficient appliances we have used. Even the form has helped in achieving like the energy performance. So coming to the circular economy, we had tried to create to create circularity in built environment using space efficiently and reduction in the consumption of waste. And like we have a waste management system and multifunctional spaces. Also we have tried to create a sort of app which we'll talk about it later, but it also helps to like reuse stuff in within the community. Coming to the social sustainability, we have created like a common kitchen, common shared kitchen, and common like washing areas in the society, and also shared an interactive space. And different spaces are open, like multi community halls are open for giving to rent. Since social sustainability, we had to create more interactive space. So that sort of space we have tried to create. Coming to the engineering operation, our structural grid is as such that we try to avoid any sort of interruption when coming to merging of our two 1 bhk, like one bhk and one 2 bhk, or either making it like one 3 bhk, making it into one 1 bhk and one 2 bhk. So the beams and columns can be aligned as such. Coming to the resilience, we have like the provision of rainwater tank, space for community shelter on, right, on-site energy generation, and also elevating the plinth level have helped us in like a lot of since it's a non-flood prone area, but still like disaster management, it helps us with the disaster management. Provision of refugee area is also there. When coming to the affordability, how we have used like designing like the flexible layout, how water efficient solutions have also achieved us and like helping achieving the affordability. The main reason, one of the main reason is to achieve affordability was to make our building completely maintenance free. So we have solar panels, like around 50 solar panels, which are catering like to the common spaces. So the all the electricity of the common spaces have been like is, coming from the solar panel. Also, since we are renting out the multi-purpose hall, so all the prior like the money coming in from there, it will be used for the maintenance of the building. Coming to the communication, the use of social media handle, like we have tried to use Instagram to spread awareness. Also innovation, coming to the innovation, we have waste collection, community and sharing, electricity, fire, livability, and different side of bio wall we have used. And health and well-being, we have like podium for outdoor activity, and a lot of like achieve like how we have achieved maximum input of the sunlight and thermal comfort through IMAX standards.
It is essential to create an algorithm for the harmonious and optimum working of the entire system. Since we are talking about having water management, solar energy, waste, passive design, innovation, and all of these things mentioned over here, creating a loop and a structure of interdependence is essential. For example, water management is important, but saving costs is also essential element. Hence, we have created a balanced equation through interdependence. You can go to the next slide.
So coming to the climate analysis, Mumbai has wind directions coming from west and southwest direction. It has a warm and humid climate, and if you see the dry bulb temperature map, you can see how there are a lot of uncomfortable hours, which are considered temperature above 28 degrees Celsius, but especially in the months of March to June. Lastly, coming to the precipitation, it has an average annual rainfall of around 2500 millimeter, which has to be catered to. On the right, we have some strategies which we have looked into to cater to these problems. So for wind, we have two towers which helps with by splitting the mass, which helps with cross ventilation in the external and even in the internal layout. As you can see in the GIF, you can see there is cross ventilation happening. Coming to the solar radiation, there is self shading which is provided with the help of the two towers. We've created green pockets on the ground and first floor level, which helps decrease the temperature. And the customized windows help which have incorporated solar shading devices and louvers, which helps with the radiation. Lastly, coming to the rain, the precipitation, which causes floods. So because of that, we have elevated the building to combat floods, and even the windows have strategically provided like louvers to let in the wind but block the rain. Next.
So coming to the form development, there were few challenges like massing to allow the smooth circulation of the wind, completely like fixing on the one iteration to like internal layout so that internal layout is flexible and modular. Also to design optimum like windows and solar shading devices so that more sunlight comes in. On the right hand side, we have like a few massing iterations which we have initially used, and the left hand side is the final iteration. This is the floor layout of A wing and the B wing. A wing includes a 3 BHK, which is given back to the redevelopment people. And in the base case and the design case, which we worked on, there are the pricing differences. For the base case, right now in Kandivali, the 1 BHK price ranges from 1 to 1.5 CR, whereas in design case, in our case, it's 90 lakhs to 1 CR. And in 2 BHK, it goes from 2.2 to 2.3, whereas in our design case, it's like 1.2 to 1.5 CR.
So this is the ground floor side plan. So the proposed building has a stack parking, as it saves space and money, which therefore makes it more sustainable car parking solution. And the open spaces provided can be used during festivals such as Navaratri, Diwali, for residents to come together and celebrate as a community. And on the ground floor and the first floor, there are like multiple amenities provided for the community engagement. Next slide. Such as community kitchens, multipurpose halls, gyms, children daycare, and so the most versatile of them are is multipurpose halls, which can be rented out, which helps in making the building maintenance free and can also be used as isolation rooms in the face of a pandemic. So this community spaces helps in social sustainability. Next. This is the terrace plan. So like keeping the solar radiation in mind, the building has the facility of solar panels and solar water geysers, which caters to the total energy to be consumed in the common spaces. Next slide.
Over here, we're talking about the landscape. We have incorporated multiple strategies to reduce the water consumption. Since we are talking about interdependence, landscape is really dependent on the water consumption. So we have basically incorporated percolation pits, maximize green spaces with native plants, and it is really essential that we're talking about native plants because native plants require minimum to zero water consumption. Podium has native plants with flowers to make the area more attractive, while again the water consumption is reduced while a more cooler breeze is induced. The ground floor is left open for the community use, such as Garba, as seen as the community is interested in Garba and enjoys it. A very elaborate podium, as mentioned, as seen in the plan, is also proposed. Next slide, please.
So coming to the near net zero energy, how the baseline of the baseline EPI was 60 kilowatt square meter per year. The target was 30, and like the minimum target was 30, and how we have achieved a EPI of 23.1 kilowatt square meter per year by using strategies such as north-south direction, optimized wind flow, natural ventilation, and window design, using appliances of 4 to 5 star, also using hot water and like solar panels and solar geysers. Also, how much by using all these strategies we are saving on electricity in Mumbai, and particularly like 1 BHK and 2 BHK. In 1 BHK, we are saving up to 10K, and in 2 BHK, we are saving up to 13K per annually. So this was how we have reduced the energy consumption. Coming to the solar PV calculation, there were few challenges how to use the utilization of the rooftop space. Also expensive, like it was expensive to store energy. So all the energy coming from the solar panels has been used in the common spaces, and the energy restored per month is around 3960 kilowatt hour per month. So that has been given back to the grid by net metering restrictions. Also, there are strategies like all the solar powered common info, like all the common spaces, including multi-purpose hall and like street lights, stack parking, everything has been used on solar panels.
Coming to the window and solar shading devices, there are 4 different types of windows as shown in the diagram on the left side. The combination of louvered, casement, sliding, and pivoting windows create these windows. Benefits of these windows are they're strategically placed, and also they help in reduction of artificial light and cooling systems. They allow for proper internal ventilation and also do not hamper the visual connectivity. Lastly, it blocks rains and even the mosquitoes, considering that's a big problem in Mumbai. Next. In this tag, we're just trying to show, we just focus on the two windows, which shows how these combination of different types of windows actually helps with smooth wind movement, blocks rain, as allows for visual connection, and allows for wind movement as well. Next.
Mumbai houses a diverse population, and every individual's requirement is different. Families grow and require more space, giving the option to scale 1 or 2 BHK into a 3 BHK by the combination as showed in the top left. Improves the sellability of the entire plot. Also, in case of expansion, 1 BHK and 2 BHK can be mirrored to be made into a 3 BHK, as also shown in the GIF. Also, the type of in the re, in for redevelopment, we have given 40% extra FSI for the people who are already residing over in the place. So basically, a 2 BHK can be converted into 3, 1 BHK is converted into 2 BHK, and 1 RK was converted into 1 BHK. Also the module, each individual module is designed in a self-sufficient manner. Hence, it gives a possibility to scale the arrangement in various manners, with some examples given as parallel arrangement, mirror arrangement, and linking arrangement based on site conditions and requirements. Next slide, please. Hello. 1 BHK. Basically, the idea was to cater to different needs and at different times for different persons. For example, for 1 BHK iterations, for example, for a single person living, a living area can be converted into a bedroom. Bedroom can be converted into a living area, and also expand it into the dining area. And we have also proposed a 300 to 450 deployable wall, which can be made by marine plywood, which is used to obtain thickness and sturdiness, which can be also converted into a Murphy bed deployable table, and also a study table. Given the storage is also there. Next slide. Different iterations here show that the versatility that can be achieved within the 2 BHK flats, with the addition of 2 to 3, 300 to 450 deployable walls. One of the iterations shows that how 300 with deployable walls act as a storage and wardrobe spaces for the two bedrooms. They can also transform as a workstation for the same. Next slide, please. Similarly, as we are talking about the combination of 3 BHK, here we showed the combination wherein, if the family expands, we can change the walls, we can expand into multiple bedrooms, and also give more open space in the living room. Next slide. Over here, we have tried to reduce the water consumption as much as possible, since Mumbai receives heavy rainfall and the amount of rainfall is high. We have incorporated strategies to catch rainwater, use rainwater in such a manner that it can be used throughout the year, and basically we have tried to achieve a net zero cycle, in which we are also giving out the water, giving out more water as consumed, to and the water can be given to multiple pesticide factories in the area. The residential towers are divided into two parts, Tower A and Tower B. The total water requirement as a combination is 72,000 liters per day. And as also shown in the landscape, we have used native plants, so the water requirement is minimum. And wherever, so we have used native trees wherever possible. The amenities include gym, multipurpose hall, shared washing room, shared kitchen, society office, indoor play room. And the total rainwater harvesting calculations, we have tried to increase the total surface area on the roof, because the water caught at the roof level can is pure and can be filtered to potable needs. Although water which is caught at the ground floor level, at the podium level, cannot be used for drinking purposes. Also, we have incorporated. Next slide, please. We have incorporated dual flush tanks and high pressure power assist, so that the water consumption is reduced by 50%. We have incorporated aerators at each tap, so that the water consumption can be reduced to 20 to 40%. Also, it is really important to make people aware about about the conditions so that they also reduce water consumption. A rainy is a device which we have incorporated into the downtake pipes itself, which filter the water in the downtake pipe itself. Also, uh, as you can see in the map, in the graph, we have shown the base case and design case. The water consumption is drastically reduced in the design case through these strategies. Next slide, please. We have incorporated eco STP, which recycles 80 to 85% water, and also the area requirement is 1.2 square meters. The really key factor about this eco STP is that uh, anything can be built upon it. It does not smell. It does not has any kind of a noise. So basically, you can even build a children's playground on the top of it. Also, the yearly savings for a conventional STP versus an eco STP that we have used is also less. So the amount of money that is saved throughout the years very much helpful. Next slide, please.
So coming to the management of waste, challenges of solid waste management in the building are like there is no proper segregation of waste at source, inadequate segregation techniques, slow adoption of in-house composting, and lack of monitoring in housing societies. So according to the data collection, waste generated per household is 2.5 kg, and the total waste generated is 367.5 kg. So for management of waste in the building, primarily it is segregated into two bin systems that are organic and inorganic waste bins. According to the total waste generated at the site, inorganic constitutes 60% and organic constitutes 40%. So at a site level, three bin system has been used, which also includes e-waste collection. Inorganic waste is treated by sending the waste to a waste treatment facility, and for organic waste, Excel Bioneer is placed at the site to decompose organic waste within 24 hours. And e-waste can be sold or exchanged by organizing camps and stalls, which help with the help of app within the society to avoid wastage, or it could be sent to the recycler vendors. Next slide. Coming to the resilience, so our structure is protected against seven major hazards: local flooding, urban heat island effect, which is in the rise in temperature due to heat wave, grid failure, water shortage, fire emergency, lack of community resilience in crisis situations such as COVID. Elevating the building 3 meter above the stilts and step down one open space on the ground has been done to prevent local flooding. And green terraces on rooftop landscaping on ground and podium, and green walls on east and west facade to tackle the increase in surrounding temperature. On-site energy generation for powering the electrical equipment with the site and inside the structure in the case of grid failure. On-site recycling of grey and black water through STP, and on-site storage of rainwater through rainwater harvesting tank on ground to prevent water shortage. Multipurpose hall, adaptable as community rescue, shelters and open ground to build community resilience, and provision of refuge space on every alternate floor in case of fire emergency. And lastly, multipurpose halls on ground and first floor can also double up as an isolation wards. Next.
So coming to the innovation and communication, we have an app which has many parts to it: community, electricity and water sharing, security, fire safety, and modular housing. We also have shared community spaces such as washing room and kitchen, which helps with social sustainability. Lastly, we have a bio wall, which helps to firstly decrease the radiation within the structure, and also because we have mosquito repellent plants, and it helps it no water. Negligible water use. We also use a hydroponic system. Next. For communication, we have a Instagram page which helps us spread awareness through different social media platforms. We also have a lot of videos which engage people with our understanding. Next.
So these are the few renders of the few spaces, including pergola, ground, stack parking, children playscape, podium mounts, and yeah. Coming to the appendix, these are the calculation of the building area program showing how much, like we have 96 cellular units and rehoused are 49. Then how we have used like the reduction of construction cost we have used by using of AAC blocks. Then cost savings on the water and reduced demand supply on energy, how we have maintained that and turning waste to value. coming to the solar and water heater calculation, how we have provided 250 square meter of area for both solar panels and solar like geysers. So the total number of solar panels are there are 50 and water heaters are 150.
In the base case, basically we have divided the water consumption as per activities: bathing, flushing, washing, cleaning, washing utensils, cooking, drinking, and PV cleaning. So the category of water consumed is different for different activities. And in the design case, as the strategy mentioned earlier, can be reduces the water consumption accordingly. So in the base case, the rural consumption per person per day was 135 liters. In the design case, it is reduced to 98.145 liters per day. Uh, Next slide, please.
Team, I'll need to ask you to stop right
Yes,
there.
sir. We are done. This is the landscape legends and these are the electric layer. Done, sir.
All right. Thanks, team. Thanks for your presentation. Now we'll bring on our jury members to take their comments. Yeah, Dheeraj, you want to go first this time?
Okay, so I was on mute. Sorry. Nice, crisp presentation, team, and happy to see that the collaborative effort and focus on respective areas where you have worked on, giving you some desired output. So I got two questions which are other than the comments, whatever we asked. Okay, before I ask those questions, excited to see the app and the vast inputs or the insights which you are trying to build into that app. I think that's a good thought, very innovative, and creating sensitivity amongst the people who are going to reside there, and that is going to help you in sustainability. And it will be important for you to see that not only it is utilized during the initial phase, but how do you make sure that over a period of time people live over there, use it for sustainable reasons. That's one piece of advice. How do you do it? How do you integrate that into your design is what you have to see. My question to you is, this being a redevelopment project, uh, how much percentage of the efforts or the design insights you have given to the developer have been accepted, gone through, detailed out, and accepted?
Sir, so the initial, so can you hear me?
Yeah, I can. Thank you.
Sir, so there were, since we showed you the massing iterations, just let me go to that particular slide. Yeah, so can you see the slide?
Yes, I can.
Yes, sir. So, showing the right hand side, we showed like a lot of plans, including all the iteration had floor plans and like different layouts. So they, in particular, there was some a problem of the grid layout. There was some problem of the cost. There was some problem of how to like modularity will be there. So like then when we came to like our final design, which is on the left hand side, they really like the idea of like creating a modular flat of a 3 bhk, which can be. So sir, what we are doing is, what we have to do is like we have to give back to the redevelopment people. So the 3 bhk flat, and we have to add 40 personal addition fsi. So those the people who were staying in like 700 square feet flat, we have to give them like around 1100 square feet back. So what we did, we provided them with like 3 bhk, in which like if there are old people, so they can like convert 3 bhk into 1 bhk and 2 bhk in one flat, they can stay and give one on rent, which is usually what happens in Mumbai. So to like ease their life and all that, so they do, what they do is to give the flat on rent. So this idea has been like our developers really like this idea, and they're trying to like use this particular idea. Even the orientation of the wind and use of the like the structural layout, like how what we are doing, like not including any columns in between as such. So even if the 3 bhk is split into two, so it can provide kitchens on both the sides. So that way, like that idea has been like developers have really liked what we have provided.
So also,
Okay,
our sorry, yeah. So the goal
but
was to have a balance. So like we had to reduce the FSI consumption. We had to also cater to the people who are already living there. Everybody, there was this argument that the developers strike with us, that the person who was living on the fifth floor wants to live in the new building, in the new structure also. He wants the fifth floor or the floor above it. So all these things can also be then managed easily. So that is how we will try to incorporate everyone's need.
Yes, sir.
Okay, I get your point. I mean, you try to localize your solutions, looking at what does the city demand and how do they live,
Yes,
and
sir.
you try to integrate your design with that. Happy to see that. Second thing, which comes to my mind is this being a redevelopment project. You had ample opportunities around reuse and recycle, but we did not see any of those things in your report. Any specific reason you are not able to integrate that part or aspect in your report? Or did we miss
So the
something? Or did I miss something?
So the actually the structure which is currently there, it's basically three structures of different heights, and they are spread across a very in the entire site, the entire plot area. So we were actually not able to use any of these previous structures for our new structure, for the new construction, because the condition was also very dilapidated. Also, there's no landscape. The entire area is done with plinth, like it is PCC. So basically, water percolation, all of these issues could not be tackled easily. So it was better to give a new construction and move forward with it. It was taking more amount of money to it will take more amount of money to first better the condition of the previous structures and then construct a new plot. And other than that, our proposal is for 22 floors. The column and the foundation for the current structure could not take the load.
My question was not towards reusing the same structure or the building. It was more towards when you pull it down, how do you reuse and or recycle what you get from
Okay.
pulling it down? Okay, no worries. I get a part of my answer. And that's all from my side. Thank you. Over to you, Srijit.
Thanks, Dheeraj. Jiten, you want to go next?
Yeah. Uh, Team, congratulations. You've taken up a redevelopment project which is very complex. And so it's a very good effort. uh, You've added Solar Decathlon to an already complex project. uh, and you achieved something is commendable. Uh, uh, I'd like to ask you to explain the solar hot water system. Okay. How did you do your calculations and how many units are required?
Sir, can you see my slide?
Yes.
So, sir, we calculated how much water can be will be required per day, like by like one person in particular. Like hot water will be required, like for what all use, like bathing, washing utensils, cleaning house, and what like other we have added like extra for washing clothes and all. So include like we particularly kept that in mind, and when we calculated that, so there was total of for the amount of water that need to be hot water we need was for 44,000 LPD. So what happens, sir? We are using the area which has been allotted for solar geysers is 250 square meter. So and what we are using is we are using one solar geyser of 1.5 square meters, which has a capacity of 300 LPD. So using that, like if you calculate that, we will the solar output, the total output of the solar heater will be 45,000 LPD per day. So that way, like we have 160 on site, and like we are required 150 only. So that way we are catering it like to the people back with the geysers.
Very good. So two
So
comments
we
I
did a
have to make.
market survey for this. So we called
Uh,
India Mart and all, and different, like we went to different sites and they showed us like different sizes. Like it was varying from 1.5 meter square to 3 meter square in solar geysers, and capacity was 500 to 700 LPD. So we took like which is like sufficient for us. We took that and like the cost effective. So according to that, we have
Very good.
done.
So, two remarks. Uh, Excellent flexibility of flats and spaces.
Thank you.
Right, you've done a great job to increase the salability and use in case of pandemic, isn't it? You looked at two. So very good. And your app is also very innovative.
Thank
So,
you.
so congratulations, and over to you, Sridhir.
Thanks, Jitin. Samit, do you want to go next?
Yeah, thanks. Thanks, team, for putting the effort. Really, I always appreciate so many people getting together, putting in something like this. I just had a couple of queries. One comment, or at least one something which I observed in the report was the proposed budget, and that seemed to be twice the partner's estimate. So I'm just wondering how will you get your partner to sort of build this idea, convert this idea into something which is buildable. That is one thing, and yeah, you can go if we have a sort of if you looked at it.
So there has been a mistake from like I don't know like I have like we have seen the report. There has been a mistake. So the
All right.
proposed budget, the budget that developer gave us was the construction cost was 20,000 to like 20,000 per square feet of the construction cost, including everything like the whole construction and everything. So that goes around 70 cr. And what we proposed was like around 60 cr. And if you exclude the like everything the price and all to give it to back to the redevelopment people, so you have to give it like when you do a redevelopment project you have to give that some amount. So including that also in mind, what we proposed was 14,000 per square feet of the construction cost. So I think that so there has been some mistake in our report which we will like look into.
All right. No.
Yes.
Can you tell me something about the eco STP?
Yes.
I saw it in your presentation, and I was just hoping
So,
that maybe more detail. Yeah.
basically the eco STP, it's actually a new concept. It's basically conceptual. It's being used it's being used in a couple of places in Karnataka and also in Bangalore. And So basically the functioning, it's using anaerobic system. So basically it removes the smell. So there is no question of smell. Also, uses three stages of filtration. So basically, the water it has three stages. So the quality of water improves through each stage, and then it can get out from the other end. Also, the technology works on power supply and daily surveillance. So, I mean, the area required is based on per kiloliter it wants to recycle. We are recycling approximately 130 to 133 kiloliters per day, which require an eco STP of 160 square meter. And also the best part about this eco STP, why we are using it is so maybe the initial installation cost can be high, but if you see, that is why I mentioned this graph on the right bottom corner, wherein we are talking about the yearly savings as opposed to a conventional STP. So I mean, even if my installation cost is X rupees, um, and Y rupees is my working cost, I'm reducing the working cost over the years, so it becomes more sustainable. It becomes more efficient for the entire community, because they have to pay for the electricity bill has to be paid and other things. Other than that, one major biggest problem in Bombay is about space. Now, if I'm gonna put up a STP somewhere in the compound on the ground floor, wherein I cannot even park on above it. It will smell a lot. I don't want all of these things. I'm already short of space. So why not go with this kind of STP where I can build anything above it, because it doesn't has noise. It doesn't smell. That is the two main problems encountered. actually, even wherein people, I mean, the government is it has made a regulation wherein you have to have an STP based on the size of the construction and the number of people living in it. So let's say for a township, you have to have a STP based on the number of houses. But people now probably go for these STPs which are allowed. That's one of the biggest problem that I think we have found so far in the study. So that is why I want to go for it.
Is it a vendor who's doing this, or is it sort of technology available for everyone to use?
Yeah, we have a
And
vendor.
has it been used
We have a
has it
vendor
been
with
used in kind of? There's a vendor, is it?
yeah, it has been used in a couple of places in Karnataka and Bangalore. I
What
mean,
kind of projects?
and this is sorry.
What kind of projects were they used in? Because this is anaerobic. I mean, it's very difficult to usually use anaerobic in a residential setting. So I'm just keen to sort of understand in what kind of projects they've been used in.
I'm sorry, I cannot hear you properly.
Do you know what kind of projects they've been used in, whether it suits a residential kind of an application?
Yes, actually, that is one gray area. I talked to the concerned person. So the point is that it is a concept. So they have used it in a couple of places for as a trial basis. So even if I want it for a residential use for a residential use, so he can modify a couple of things, like he can reduce one stage or half a stage. He can change the working of the entire, like the basic working will be the same, but a couple of components can be changed so it suits for a residential place. Yeah.
All right, thank you. Back to Srijit.
Yeah, thanks, Amit. Thanks, team Inferno, for your presentation. And now we will go for a break. Uh, the break we are breaking early, actually, 10 minutes early. We'll be back at 2:30 p.m. That's in like about an hour. And Team Nivas 2.0 will be presenting next. And I request both the team and the jury members to join back before 10 minutes, around 2:20, if that's okay with you. And yeah, so we'll catch you all after the break.
Thank you
Thank
so
you,
much.
Srijit.
Thank you.
And thanks to Team Inferno. Appreciate your work.
Thank you.
Thank you so
Thank
much, sir.
you.
Thank you
Bye.
so much.
Thank you.
So, welcome back, everybody, to the multifamily housing division presentations. So, we are going to continue with our presentations now. The fourth presentation is from Team Nivas and Nivas 2.0, and they have worked on Project Homeground in Pimpri Chinchwad, Pune, Maharashtra, and their project partner is Mahindra Life Spaces. So let's do a quick AV check. So right. Priyanshu, can you do a quick AV check?
Hello, am I audible?
Yeah. Brunel?
Hello.
Yes. Cool. Kausar?
Hello, am I audible and visible?
Yes. Loud and clear.
All right, perfect.
Pranav?
Hello, am I audible now?
Yes. Yes. Okay. So same old instructions, but I'll just repeat it for you guys again. So let's start with you guys going into the presentation mode. Can you start sharing your screen?
I'll share the screen. Okay,
And
my screen is visible.
Yes.
Yeah.
And can you go into presentation mode?
It's visible?
Yes.
All right, perfect.
Okay. Yeah. So team, you have 25 minutes for your presentation. At 20 minutes, I'll ring a bell like this. You heard that?
Yeah.
Okay, cool.
Yes.
So I'll ring a signal like this, and you'll have 5 more minutes remaining for your presentation. You won't get a 26th minute, which means that at 25 minutes, I'll have to give you a hard stop. And after that, we'll have a 15-minute Q&A session with jury members here. Okay, so the stage is all yours. All the best.
Yeah.
Thank you.
Yeah. Sorry. So good afternoon. My name is Pranav Raj. I'm a member of Team Nivas 2.0 here to present our team's design proposal for the category multifamily housing. Before I get into the details of the project, a quick introduction of my team. We are a group of students of 5 colleges from disciplines of civil, mechanical, and electrical engineering, and architecture students with our faculty lead, Professor Gunjan Kumar. Our project partner is Mahindra Life Spaces, and our project name is Mahindra Homeground. The site for the project is located in Pune, Maharashtra, in Pimpri Chinchwad. The soil type is black cotton soil, and the foundation we propose is raft and pile foundation. Climate analysis of our site. Pune has a warm and humid climate. Our site receives around 2,870 hours of sunshine throughout the year. Analyzing the climatic condition, the months March, April, May, and June are observed for the maximum dry bulb temperature, and mid-June to end of October for high humidity and rainfall, and November, December, and mid-January are observed as winters. Talking about our site area, it is 12,423.85 square meters, which is approximately 3 acres. The total built up area is 66,368.45 square meters, and the ground coverage is 37.45% of the whole site area. The total number of towers designed are 4, and the total number of units are 484 units, which comprise of 1 BHK, 2 BHK, and 3 BHK, along with the podium floors for the parking. The main goal of Team Nivas 2.0 is to design a net zero project through architectural interventions, energy efficiencies, good water management, and ensure health and well-being of the users in the building. Our team has imbibed behavioral changes by adding technological innovations to engage the residents in net zero initiative. As you can see, the building is oriented towards the south, which results in the maximum solar heat gain on the south facade. Through SWOT analysis, we understood the strengths that we observed the maximum wind flow from the west and the northwest side of the site throughout the year, and there is adequate amount of sunlight on site for 188 days throughout the year. The weaknesses, as Pune is a flood-prone area, we consider it to be the weakness of the site, wherein the annual rainfall is around 722 mm, and the threat associated in building the building would be the risk of structural instability due to waterlogging in large quantities during floods, and the opportunity on site would be to make structurally stable, which would be flood resilient, and to design a net zero building due to the availability of the natural assets like sunlight and rainwater. The first design intervention is taken forward by rearranging the service course from the center to one side of the building such that there is a formation of a courtyard in the center that facilitates ventilation through windstack ventilation and also allows a lot of sunlight into the building. The team has performed computational fluid dynamics analysis in the Design Builder to confirm the efficiency of the intervention. As you can see in the image on the right, wherein we can observe the result of increased natural ventilation compared to the base case. The CFD studies illustrate how minimal changes in base design can effectively improve the natural ventilation of the place, the overall enhancement of comfort and performance of the building in terms of energy, and improving the healthiness quotient of the place. Along the fenestrations, we have attempted to increase the green elements in the building by placing planter boxes on the sill level of the window. We have proposed to construct overhangs and side hangs of around 700 mm by the amount which would reduce the amount of solar radiation entering into the building. As this is the green terrace intervention, as work from home has brought in light to need of areas of green lungs wherein the families could go and relax, the team has felt important to create certain leisure and recreational spaces up at higher levels. These can be private spaces exclusively for the units around it, and can also be open to those who want to buy in and use the space. The concept of creating terraces at 8 floors in space between 2 towers and intermediate floors. These sketches briefly illustrate the idea of green terraces. For the next design intervention, we have used parametric design to limit the solar heat gain on the south facade, which is exposed more to the most of the solar radiation due to the orientation. This resulted in reduction of energy requirement for cooling. These pictures demonstrate the use of parametric facade on the south facade of the building. The section shows the number of levels and the height of the building. The construction materials used are AAC blocks, Lloyd PUF foam on the roof, the Saint-Gobain 167 glass and Viridian glass for the fenestrations, the rat wrap masonry along with high SRA paints, the glass wool insulation and RCC Mivian framework, which has significantly reduced the heat gain on the building. These materials have helped contributing in reduction of the total heat gain and also supported in reducing the total energy consumption throughout the building. Now my teammate will follow up with the energy segment.
The main challenge we faced in our way in achieving net zero energy is the project being a high-rise tower with a very high amount of wall being exposed to radiation. Highlighted points are the major challenges we faced, along with other factors like the non-uniform power rating of the equipments used by each dwelling unit. These are the reasons why we have prioritized nullifying energy consumption in the common areas by demand reduction and also by using strategies like dimmers in the outdoor lighting units and all the other highlighted points on the right hand side. Also, we have tried achieving net zero energy through renewable energy generation. For this slide, I'll ask the respected jury members to please keep an eye on the flowchart for the ease of explanation. For the base case, we have found EPI to be around 96.18 kilowatt hour per meter square per year. We developed total 7 design cases and 3 composite cases. With my one wall intervention, our EPI was reduced to 90.51. After considering ECBC, super ECBC walls and roofing, efficient lighting and equipments, EPI is reduced to around 46.42. And finally, after RE generation, which is around 190 megawatt hour per year, final EPI is reduced to 33.76, which is the most efficient case. I'll be explaining the composite cases that we have considered for reducing cost in the further slides. This is the EPI reduction graph. Base case EPI 96.18, most efficient case 33.76, and the most economical case is 41.24. We are able to generate around 75.4% of the total power consumption through RE generation using rooftop area of all the towers. We can either generate from an off-site area owned by the developer nearby, where a plant of 89.63 kilowatt peak and an area of 144 meter square is required to reach net zero. Or a third-party green power purchase can be opted, which includes either partial power purchase of 24.6% or complete power purchase. After that, we have done the artificial lighting simulation. Power consumption due to lighting fixtures was reduced by 16.5% to that of the base case. The lux levels are considered as per the IS 3646 standards. Glare observed in the base case is controlled by mutual shading of 4 towers, and our selected class with shading is providing 2.2% extra daylight area without creating discomfort to the eye. Hence, we have selected the Viridian class to have more daylight area. Now, this is our most economical and affordable case, the composite case. By the word composite walls, we mean using high thermal mass materials and efficient glazing only for those walls where we receive highest amount of radiation. For the rest, we go for lower cost My1 structure walls and the ST167 classes. We are recommending 3 composite cases. Thus, we are getting a reduction in EPI of 32%, 44%, and 57% respectively on base case, and reduced EPI is 41. Along also, the savings in cost from design case 4 is 6.72% for composite case 1 and 7.18% for the composite case 2. This diagram shows the following strategies implemented, which gives an EPI reduction flow at the right side. Now, to cater to the social well-being, we have designed the green terraces, which we already have come across. Our site has jogging tracks, badminton courts, a multi-purpose clubhouse where people can gym, play indoor games, watch movies, and enjoy together, which in turn gives them a huge sense of amusement and pleasure. Visual comfort plays a major role in assessing one's health. Highly energy efficient dimmable LED lights and efficient glazing are being integrated for occupants' visual comfort. Now, in order to cater to their thermal comfort, we studied the psychrometric chart, and it was clear that 56% of the yearly hours, no active cooling measure is required. Studying the monthly temperature ranges for Pune, we suggested the month-wise cooling techniques to be deployed. It has been inferred that monthly average temperature rises up to 27 to 29 degrees centigrade in the months of March, April, May, and June, which is more than the annual average temperature. So active cooling measures are required for only these 4 months in a year. For the remaining months, passive techniques and natural ventilation can keep the units cool. Now, for the following 4 months, we require mechanical HVAC systems for the towers. Our base case was the use of 3-star split ACs and ordinary fans. We proposed a solution like why not using 5-star rated split inverter ACs in conjunction with BLDC fans? As per the study laid down by the Center of Advanced Research in Building Science and Energy CARBS, AC on fan speed between 1 and 3 is ideal for indoor conditions. With the same philosophy in towers, if the AC runs with a higher set point of, let's say, 27 degrees centigrade along with a BLDC fan running at a speed of 0.5 meters per second, indoor temperature can be lowered up to 3 degrees centigrade. According to the BEE guidelines, each degree rise in the set point temperature saves 6% electricity. Now, here are the internal CFDs performed for a 1 BHK flat for optimal positioning of split ACs, BLDC fans, and for airflow pattern through natural ventilation. For the beautiful clubhouse we have in our site, we have explored 2 scenarios: VRF system, evaporative cooling system, to find which one suits the best. We have designed and actively sized both the systems and compared both in terms of comfort hours, energy efficiency, and cost. We have used the software EvapCare, a brand new and the nation's first evaporative cooler sizing software by eShri. These are the indoor and the outdoor systems specifications and selections for VRF at the top. For evaporative cooler sizing, out of the 8 rooms, we have clubbed the adjacent individual rooms into 3 zones and suggested 3 units of 5658 CFM, 5248 CFM, and 2985 CFM. Peak power savings with the evaporative cooler is 64.3%. We have also done detailed cost analysis for both the systems and compared both. Total cost incurred in VRF system is 12 lakhs 11,000 rupees, while in evaporative cooler it's just 9 lakhs 68,000 rupees, which is a way lesser than the VRF system. Hence, we recommend the evaporative cooling system in the clubhouse, as it is not only catering to 89% of total yearly hours with 100% comfort, but also gives 56% reduction in the capex. We have also ensured that our energy, water, cooling systems, and construction materials are affordable too. In energy, as stated before, with the most affordable construction materials, we have reduced the EPI up to 41.24. Due to renewable energy integration, we save 77% of overall energy use. LED lights over CFL reduces 9.72% of the electric bill. Through the composite wall and glazing recommendations, we save rupees 11 lakhs 79,000 from the walls, rupees 1 lakh 19,000 from the glass. Hence, total savings of rupees 12 lakhs and 98,000 is achieved. We have several efficient plumbing fixtures to save water, which we'll go through thereafter. We have a humidity harvesting machine which collects moisture and add up to the total water requirement. This reduces the operation time and the energy consumption in pumps, and hence saves 29,000 rupees per year after 3 years of payback period. With BLDC fans, annual power saving is 62% and operational cost is reduced by 1,500 rupees per year. The unique proposal of evaporative coolers in the clubhouse saves 56% of capex over the VRF. Under the recommendation of our project partner, we have also used the affordable construction materials and techniques to reduce construction cost and timeline as well, like the My1 board walling, aluminium framework, white pigmented concrete, and flow column piping. Coming to the life cycle cost of our project, the total project construction cost base case was rupees 218 crores. Our design case cost is rupees 223 crores, which is just 2.5% more, and the payback period is 30 years. Now my teammate will continue.
Water is an essential commodity required for the proper thriving of the society. The main challenges which is the face that is the site area is comparatively much lower than the number of dwelling units present. Our approach was to reduce water consumption, reuse grey and black water, and repurpose rainwater efficiently, and the crater down the municipalities water load. And hence we summed up the plumbing fixtures based on the case studies where, according to NBC 26 standard, required the per capita per day around 135 liters, and using efficient water fixtures, we reduce total water consumption per capita per day around 89 liters. And we did 3 case studies where first is we reduce 5%, and further with closets we saved 28%. Our proposed case with closets and aerators we saved up to 46%. Our secondary source of water, that is AC condensate and grey water, is sent to the STP. Here we used a sequencing batch reactor, that is known as SBR, where treated water is used for flashing, car washing, building cleaning, and the excess water goes to the drainage. As per the meteorological data, we collected the last 5 years rainfall data, and taking runoff coefficient as 0.95. Of our rooftop and site rainwater collection is around 6,022 cubic meters, which is being stored in a shallow well dig in the site. The shallow well is helps to first not only reduce the maintenance cost, and also prevent the occurrence of insects and pesticides. Further, for the softscapes and hardscapes rainwater collection, 531 and 7,254 cubic meter respectively. IoT meter serves a major impact on our net zero projects. It helps to achieve behavioral changes, and maintenance cost is reduced per capita per day. For an example, a person who is using water efficiently, he will always give less maintenance cost rather than any person who is using without any aiming water reducing strategies. Our alternative source is water. Water is from AC condensate, where the total dwelling unit is 484 and number of unit is 2. If the operation takes place in 1 hour, then the condensate water is generated 9,680 liter liter per day. Secondly, arrow water, which is the humidity harvesting humidity harvester unit generation is 1 kiloliter per day and number of unit is 30. The annual generation is 10,950 kiloliter per annum. Hence, to achieve the net zero water strategy, we proposed saving 39% of water efficient fixtures. Rainwater harvesting saves up to 10% uses. IoT water meter saves, and behavioral changes and mindset changes up to 6%. And the further from STP, we receive saving up to 45% of proposing SRB treatment plant, which is too flexible in control. Maintenance cost is also low, and hence we are on the positive side of 101% of net zero water positive solution. And coming to the waste management part, we have taken 0.45 kg water waste per capita per day out of the 40% of our organic waste and the rest of the inorganic waste. Based on the total quantity of waste is coming out to be around 1186 kg, and the organic waste is around 470 kg, which will recycle into a biomass, which with the help of organic waste composter, which is completely fully automated PLC based bulk waste digester of the capacity of 9,000 liter, and also the time taken for the composting around 24 to 30 hours. In the transformer setting, we have done lighting and equipment load based on the flats and in the common areas, and we proposed 2000 kVA transformer for each tower and have integrated with the solar panel for the some specific appliances. Nowadays, electrical vehicle is used worldwide to reduce the dependency of fossil fuels and the achieve the global net zero carbon emission. So we have installed the different 5 different types of technologies of fast charging unit in a 10% of parking area, and also we are providing one facility of 32 ampere of charging socket of each parking slot for the future expansion. So coming to the resilience part, in the water resilience, we have installed 12 rainwater shallow wells to not only maximize the rainwater harvesting, also supply the water of any kind of emergencies. From this way, we can ensuring the water availability throughout the groundwater. In case of any fire hazards, we have installed automated fire detection system and the in the flats and common area. The fire system consists of sprinklers and hose reels. Moreover, fire extinguishers are provided on the common areas to ensure the safety and precaution against the fire. Here, we calculated the basic electrical load requirement based on that we have installed 410 kVA diesel generator set, and these generators are synchronized with the feeder panel and the automated tap changers provided in order to provide the continuous power supply. And the generators are hybrid type and certified with Central Pollution Control Board to minimize the carbon emission, and with the operation of 15,000 hours of operation with any kind of severe power cut. And coming to the network resilience part, since the internet has become a major role in major role in day-to-day life, so we have provided 24 into 7 wi-fi connectivity in our occupants. Moreover, we connected our complete wi-fi network into solar batteries, which is add the more resilient design in our building. So our team has to made sure to enough importance in the earthquake resilience. So we have proposing wrapped and pile foundation, where the building is isolated from the ground, which helps to facing the earthquake without any damage. And also the membrane braces walls and the structural strength created to the created with the help of beams and columns to make building earthquake resilience. Now the rest of the slides my teammate Kausar will continue.
Compared to our competitors, Mahindra Life Spaces, with their approach, can become net zero ambassadors, attracting customers with physical amenities and a digital intervention we will see in innovation. Our demographic survey shows a vast majority want sustainable, automated housing and are willing to pay more for it and prioritize builder trust. Over 60% also have multiple users for their flat in mind. We chose our target customers based on usage purpose and economic strength, and our USP provides savings.
Guys, your time is up. You are up with 25 minutes. Um, so I think can we go into asking the jury about their comments?
Sure.
Samat, you want to go first?
Yeah. So thanks, team. Thanks, team Nivas. It's been a wonderful effort. I mean, I think the effort comes through your presentations and your work. So there's no doubt that you put in a lot of work. Uh, just a few areas which I would sort of encourage you to look at. One, of course, being the presentation part of it, when you're looking to doing these reports, uh, just make sure that what you're presenting is readable, because it's not as just enough to make people know, let people know that you've done the work. It's, your job is to also make sure they've understood it. So I think that's an important part of the work itself. And I think as engineers, my experience has been that even I didn't, just taking from my own experience, we don't really learn a lot of this in college. But I just encourage all of you to really look at it and sort of make this a part of your effort. The work is there. Presentation is important. You only get, you've got 25 minutes to talk to us, but when you're trying to sell an idea to a developer, you might get even less. So it's going to be more and more difficult. I think that's an important part, which and it's a matter of practice. If you start emphasizing on that, I think you'll learn. A few areas which I think could have been done better. Of course, it must have been difficult trying to pull people from 5 different colleges together on this thing. But I would have liked to see a little more effort on the architectural side. For example, you've decided shading of 700 millimeters. I would like to see how you've sort of arrived. There's a process to arrive at these kind of things. So I think a little more effort on those areas would have really, I would have appreciated that. A few things to also look at, so when you're trying to do evaporative cooling, if you think is good, it will be good because the weather is dry. And if the weather is dry, then you'll probably not, get condensate as much. So you have to look at these interplays between different systems. It's difficult. I know it's not easy to really sort of comprehend all of this, but look at the interplays between different systems. And I think that will really, this is just the beginning of your career. Just thinking of this whole thing as a sort of this thing as a whole itself is a great it will be a great approach to as you move ahead in your career. But anyway, thanks for the work. It's, I mean, really good quality hard work. I can see that. Thank you for your effort.
Thanks, Amit. Dheeraj, you want to go next?
Sujit, can I go ahead?
Yep. Yeah.
Thank you.
Yeah.
Quite comprehensive work, team, and happy to see quite a things coming out. And other than what we read on the report, you've been able to cover a few things in your presentation as well. While you will also appreciate that we have to be fair to every team, and that's why Srijit made sure that 25 minutes is all you get, because every team is getting the same time. And this was, I believe, informed in advance to all of you. Having said that, coming to some of the thoughts which I have, not to take away the credit of the good work which all of you have done collaboratively. See the amount of time which you have spent on evaluating a clubhouse worth 50 tons of load. I think if you would have spent that much time on the energy guzzler, which is the air conditioning system of the apartments, trust the capacity modulation of that would have helped you in further optimizing your EPI significantly. And that optimization helps the developer in not only saving on the capital cost of air conditioning, but the connected load also comes down significantly, which reflects in the load on the generator sets also as a power backup. So see the impact which it has, an exercise which you have already done. Just try and connect. See, as I said, we are not taking away any credit from you. No, we are happy that at your experience level, you have been still able to get a lot of things on table. and Samit mentioned quite a few of them. So, but I am just trying to touch upon what you've already done. You did CFD analysis. CFD analysis can also be done for optimizing and right sizing of air conditioning as you go up the floors. Not only wind, but that wind impact on air conditioning can also be used. Being from the field, I'm a little touchy, and that's why I'm touching upon this subject and trying to impart that knowledge. Okay, so not spending too much time. That was an idea which I wanted to give it to you so that your partner can also look at these ideas. And the second and the last piece from my side is I mentioned that in my I think comments earlier. Connected homes today is the in thing. When I say in thing, means the customer demands the connected homes today. What you have done is already good work is done. You are given. What you probably need to also look at is how do I make this energy net zero and water net zero an integral part of that, which is making the complete project sustainable, not just today, but by itself. You drive sustainability as a habit who are going to be the occupants of this place. Think on those lines. How do we make that also? This will be in addition to what you already done. So solid work done. Happy to see that. And all the best to all of you. Thank you.
Thank you.
Thanks, Dheeraj. Some really great, insightful comments there. Jiten, you next.
Yeah, team, very well presented and comprehensive report. I was very happy to see it. Just one question I had was, can you elaborate on the EV charging, electric vehicle charging?
Yes, yes.
Yeah, can you
Masha,
go to
please
that slide? Yeah.
show the slide.
Yeah.
Yes, sir. In the EV charging part, we have put it the 10% of the parking area put at different kinds of fast charging units. These are the charging model. These types of charging units. These are the models, and we are our total parking area is 624 units, and we are putting the 10% of the charging unit. And for the future expansion, we have provided one facility of 32 ampere of socket of electric vehicle charging socket for the future expansion. So that's why we have already oversized our transformer.
So this CSS 50 kilowatt hour, these are what different models?
Yes, sir. Yes, sir. It depends upon the model. The CSS is charging 0 to 100% in 7 to 8 hours. These are the fast charging in this technology in this now.
And they all of them will charge the same. It will whether it's a car or a bike or anything, they will all
Yes,
charge.
depends upon the types of chargers.
Uh-huh.
Depends upon the chargers, or either car or bike may charge.
Okay, so bigger car will require 50 kilowatt hour like that.
Yes.
Fine. Thanks. So Srijit, that's it, and well done, team.
Thanks, Jiten. So that was a good presentation, a lot of content in your presentation, but unfortunately you couldn't complete it, and that's okay, I think. The jurors have given their comments to you. So all the best, Team Nivas 2.0. And we'll move on to our next presentation. And we'll move on to the next one in about 5 minutes.
Thank you all.
Thank you.
So welcome back, everyone. So our next presentation is from Team Sub-Zero. They have worked on a project, Advait Dhun, in Kirtipur, Kathmandu, which is outside India. That's interesting. And their project partner is Tribhuvan University. So let's do a quick AV check for our presenters. Yeah. Hi, Apurva.
Um, Hi, am I audible?
Yes, loud
Yeah,
and clear.
thank you. Thank you.
Rohit, you want to go next?
Yes. Am I audible?
Yes, perfect. Mandru?
Yeah.
Yeah, cool. Mandru, could you center yourself a little bit on the screen? Yeah, that's good. Yeah. Akshit?
Yeah, hi.
Yeah, hi. Okay, so have you guys started sharing your screen?
Yes, I have shared my screen.
And it's in presentation mode, right?
Yeah.
Okay. All right. So team, same instructions as before. You have 25 minutes to present your work. And at 20 minutes, I'll ring a bell like this. You heard that, right?
Yes.
Yeah. So you won't have a 26th minute, which means I'll need to stop you at 25 minutes, and that would be a hard stop. And after that, we have 15 minutes for Q&A by our jury members. And yeah, so try to keep your answers direct and succinct, and try to be to the point when you answer your questions. So yeah, the stage is yours, team. You guys can start.
Um, Good afternoon, everyone. We are Team Sub-Zero, and I am Apurva, and I am the team lead of this team. With me, there is Akshit Vinayak, Rohit Bam, and Mandru Sashuran, who will be presenting. Um, Here are all our team members, and here are the faculty leads and advisors who have helped us in this project. Um, Following, uh, we have there is our project name, that is we are working on residential housing and nursing housing for
Apurva, we aren't able to hear you. It looks
am
like,
I am I audible
yeah,
now? Hello.
yes, you are now. You are now.
Okay, okay, sorry for the it is a residential housing and nursing housing that is for Tribhuvan University, which is in Kirtipur, Kathmandu, Nepal. And our project partner is Divya Singh Shah, who is the Dean of Institute of Medicine in Tribhuvan University, Kathmandu, Nepal. And here is Dr. Anil Diwan, who is the lead of the team who is working on the master plan of the Tribhuvan University. So coming to the site of our project, the site is located to the Kirtipur, Kathmandu.
Apurva, there seems to be some. Is everybody else facing that?
Is, am I not audible? Hello?
Yeah, there's a disturbance coming in from your end. Yeah.
Am I audible now?
Yes.
Sorry for this once again. So our site. We have showed the site area, that is the build-up area. It is 27,000. Requirements from our project partners are that they needed a 20 family house 20 family houses family blocks, which has 64 nurse families and 64 residents. Um, And they has also informed us that there is a high tension wire that is passing through the site, so in which there is a no construction zone. And um, budget of is almost 28,000 square meter. The climate of Kathmandu is it has dry winters and warm summers as normal temperate climate. Currently, um, the occupants are the occupants are that uh, mostly nurses, and the residence housing are for the doctors. The occupancy time is 4 hours a day.
Apurva, again, there is no audio coming in from your side. Do any of the others want to take over?
Yeah, yeah, sure.
Yeah, okay, go ahead.
Can you hear me now?
Yes, loud
It's
and
pretty
clear.
clear. Okay. So the appliances we have used are the television, refrigerator, washing machine, exhaust fan, and the ceiling fan for our apartments. And these are like a well, like we would say, a very less voltage consumption are there. And these are the okay, this is the more elaborate things like the wattage consumption, because we have used the ceiling fans which uses 26 watts. So these are some of the equipment which we have used, some of these having the inverter technology in them. As we all know that inverter technology in recent times uses really very less amount of electricity. And for the lights also there is very less wattage, and it depends because we are tried our maximum to incorporate the daylight and use the minimum of the artificial lighting in our design. And the refrigerator, we have used a very efficient kind of refrigerator like the 5-star rating one, and it's always operates for 24 hours, and rest of the things are also used. Yeah. So moving now on to the goals, our first goal is energy efficiency. We aim to attain the EPI less than 20. So scheduling the HVAC for the winters at the time when the building is in use, and using the energy efficient appliances, inverter technology compressors. Like we have also used the inverter technology compressors in our VRF HVAC system. So it came like it helped us to achieve the EPI of 15.22. And the maximum groundwater recharge, we try to gain the maximum groundwater on our site. So like our aim is to have the at least 50% area available for the groundwater recharge. So we are like on the road, that road area is like 2720. So in this matter we achieve around 57.5% the groundwater recharge area which would be available now. So it's more than which we are trying to achieve. uh, uh, Goal for thermal comfort, aim is for 100% comfort hours. Some of our hours are very uncomfortable, like in summers it's like very less which are uncomfortable, but in winters there are huge, we actually need the HVAC system in winters because the temperature is very less in nights. So we incorporated with that, and we try to provide the 100% comfort hours. And the solar power, we aim to generate the 100% power through the solar power plant. And the power flower. So we it would say ki we have generated about 135% approximately power through the solar power plant, which is like energy positive building. Like we are generating 35% extra in terms of power. And the waste in the water management, we target per capita water consumption to be 70 lpd, but in our case, in our scenario, we have achieved 66.6 lpd using the low flow fixtures and all that stuff, and achieve 65% of the fresh water consumption through rainwater harvesting on our site.
So coming to the design part, we have taken care of the orientation of the block so that each building can have the heating and the cooling that is required during the each seasons. Uh, and as our client has told us, there is a 12-meter non-buildable area. So to utilize the most of the area, we have used it as a roads and parking. Um, Similarly, we have provided sports facilities for the residents, and as the most of our residents are doctors and nurses, they have a very hectic schedule. So to ease them with their daily needs, we have provided spaces for shops inside the society. And also the um, one of the major risks that is the air pollution and the indoor air quality. So to enhance the indoor air quality, we have provided as much as opening we can in our design. We have also provided open staircases so that the corridor can be well lit and there should be a proper circulation of airs. And also the most of the design has been taken care through the standards of NBC. These are the sections of a whole site. And another section, here we can see the height and the number of floors in each building. Um, yeah. So here is a view where we have shown how the sport facilities are placed, and how it's is connected with the different apartments or the blocks over here. Uh, Similarly, showing the another view how the balconies act with each other. And
So coming to the energy performance of a building, total energy consumption of a building is 1,63,575 kilowatt hour per year, which which is less than the total energy generated. So our total energy generated is around 2,22,385 kilowatt hour per year. So it would lead us into the energy positive building. And regarding the payback time period, it comes out to be 4 years. And all these are the calculation which you can see on the screen. And for the panel generator capacity, we have use of the 220 kilowatts, and the number of PV module we have installed on the site is 646, and model efficiency is around 18%. Number of PV. Okay, so in this system, we haven't used the batteries in our buildings. We have used the grid system, in which whenever the building uses its energy from the solar panels, it comes, and whenever the leftover energy happens, like whenever leftover energy is there, then the leftover energy goes to the grid system. And whenever the building, like whenever the solar panels are not working on that much efficiency, then the grid system gets back so our energy. So it's a difference which we have to see. And in this difference, we are leading with a 35% of the energy positive, means we are like in a 35% power positive power consumption we are giving the credits. So shading is required in the summers, and in the cold we are tried that the summer rays has been protected with the shades. And the we are in the first October is taken into consideration for the length of shading, such that summer sun is blocked for most of the time, and winter sun is allowed to enter inside it. And yeah, next. So windows, keeping the windows on the southwest and the southeast facade are maintained, and to wall window to wall ratio has been maintained to 30% to increase the heat gain, as well as the north side windows, as well as the windows of northeast and the northwest are reduced to 20% to reduce the heat losses, because it's a cold climate zone, and we also want that the heat to be trapped inside. So the energy consumption has been reduced considerably by these measures. In this simulation, we can see, like we have done the simulation on the design builder. So with that, the EPI comes down from 81 kilowatt hour per meter square to almost 43 kilowatt per meter square. So EPI, we have calculated the EPI, which is like the appliances load, the laptop load, lighting load, HVAC component, electric load, miscellaneous load, pump load, and others, and it comes out for us to be 15.22 kilowatt hour per meter square per year.
So we have done daylighting optimization using daylight illuminance from Design Builder, and with help of the simulation data, we have arrived at a data which shows that the 80% of the area inside our building has met the daylight requirements according to the Griha. For the rest of the day lighting, we have used artificial lighting optimization. So for artificial lighting, we have used Dialux software on which we have calculated the number of luminaries required according to the given formula as per the IS standard 3646 for the amount of optimum lux level required. Next slide. This is the daylighting, artificial daylighting simulations from the Dialux software. Next slide. Yeah, so from the data, these are the artificial lighting and the color schemes which we are giving in the rooms as per the given requirements of the lux level from the Griha manual. And from that, we calculated the total power consumptions and the number of hours which will be required by the particular light to give the optimum daylighting inside the rooms. Next slide. So from the data and the light loss factor and the reflection factors, we have arrived that the total lighting load for a floor comes out to be 8 kilowatt hour per meter square per year. Next slide.
So these are the some of the automated system we have installed in our building, and we have also put the data for for the capacity and the power consumption accordingly. And these are the equipments like the better quality equipment which we say which will require less wattage and less power to play on. So we are installed like we have the VRF HVAC system into our building, and we had the Green Hack dedicated outdoor air system DOS now feature. We use the inverter compressors on selected RV and RV models, offering 5 to 30 tons PDX cooling capacity. Compressors provide precise temperature and humidity control and operate at reduced sound levels. The main purpose of using this is like they can work on different levels, likewise not on the upper level and not on the only on the lower level. They can adjust their speed accordingly. And the only thing is that they help us in a lot of power consumption, conservation. Power conservation में बहुत help होती है. And on our site, it's better to use the VRF system, as we have also gone for the GSHP ground source heat pump system, but it was like the SAR site is in Nepal. So being in Nepal, it's an earthquake prone zone, and for the GSHP system, we have to do the means खोदना पड़ता है and pipeline system. So it's really unaffordable, also quite like it's quite high pricing thing, and it's quite not good to go for that system in that kind of area. So it would be really good for us to offer for go with the VRF HVAC system. And in this HVAC, outdoor unit is working differently and AHU has been scheduled differently. So both of them are scheduled differently in different bases. Okay. And from this thing, like we have the two type of apartments, type 1 and type 2. Type 1 is basically the 2 BHK apartment, and the type 2 is the studio apartment. So from calculations, like for the total type 1 units, we are using the 18 kilowatt, and for the total type 2 units for HVAC system, it is only the heating capacity 15.85 kilowatt. In total it comes out around 33.85 kilowatt. So if we convert it into tons data, it comes around 9.62 tons. So this is the capacity of HVAC system which we require. And these are the graph which shows that we have achieved, like for the first graph it's seeing that from the 1st Jan to 31st Jan our temperature range is between 18 degree to 34 degrees Celsius. It may be 34 degrees Celsius when the time when the apartment is not in use, because we have scheduled the HVAC system when the apartment is in use, and according to that time it's comes around under the range of the comfort temperature. And on the next graph, which is the our can please which is our main concern is like the winters, because there is so much of cold climate is there. So from 24 December to 31st December we have achieved a good 18 to 22 degrees Celsius temperature between our in our apartments. Okay, next. So as if we see that 18 and 22 degrees are not in our temperature range, like the comfort temperature range, but according to the adaptive thermal comfort model, we can increase, if we increases the indoor temperature by 6 to 8 degrees Celsius, and we can achieve a limited comfort, and rest of the comfort can be achieved through clothing factors and many other things like mainly usually clothing it. So this is how we achieved, and we saved a lot of electricity in going with that way.
So coming to the water performance part, we have shown the annual consumption of water over here, that is 58 lakhs and 40,000. Uh, the harvested water from the harvested rainwater is at thir- uh, 33 sorry 3,562 kiloliters, and the water that we take from municipality is 2,278 kiloliters. This is the water cycle that that you have used in our design, the how we have collected and the through which means we have transported. First, the collected water is transferred to the underground storage, then it's treated and transferred to the other storage, and through which it is transferred to the portable tanks that is above the building, and which is further used in the different uses like kitchen, drinking, cooling, drinking, cooling, bathing, wash basins, etc. And the grey water uh, that we get is then further treated and reused for flushing and um, flushing and are used for irrigation. Yeah. And this is the rainwater harvesting chart that you have shown, that in which month we harvest how much of rainwater. And in the next one we have showed our storage and the total freshwater demand. This is our detailed rainwater harvest and the municipal water supply, and also our demand, the grey water generation, the irrigation water demand, and the grey water used for flushing. Uh, uh, we have also used the low flow fixtures through which uh, we have consumed we have sorry we have by using the low flow fixtures we have reduced our consumption by a great margin, as we can see through the base cases. And um, our next is our water tank sizing. We have one tank of 5 lakh liters that is installed in underground, and also there are RCC water tanks that are each storage of the 3,500 liters that is placed over the blocks, and a grey water storage tank that is of 3,750 liters. Yeah. And we have Rohit, could you like to continue this?
So we have used biological treatment plants with very high efficiency of 95%, which reduces the freshwater demand using the ultra filtration and ultraviolet lighting and chlorination, and reduces the water demand by 20%. Next. So for health and well-being, from the uh, psychometric analysis and from the design builder, the data shows that thermal comfort is achieved for the 70% of the time, and for the rest of the discomfort hours, which is 923 hours of winter and 639 hours of summer, the VRF system gets activated. Next slide. So with the help of the VRF system, we fed in the design condition data, and we achieved the 100% thermal comfort. Next slide. We also use landscape strategies like giving the uh, trees which develop very fast with strong root system, and which give shadow, also flowers and fruits. The landscape used, the trees which we use are local to the climate of the Nepal. Next slide. For air quality management, we are providing a air filter which gives feedback data via an app regarding the particulate matter levels in the air. For water storage, we have provided concrete tank instead of the syntax polythene. Also, we have given low VOC compounds and low VOC paints to reduce the amount of volatile organics in the air. Next slide. These are the technical specification for the ultra zero VOC compounds which will be used in the building. Next slide. For resiliency, because Nepal is an earthquake prone zone, we have given a confined masonry structure along with tie beams and tie columns. And instead of normal brick wall, we are using hollow concrete block wall, which will be also reinforced with steel bars. Next slide. So, with the help of the steel bars and the confined masonry, the vibrational forces of earthquake can be transferred better to the structural grade. We are also connecting the building app to the Nepal Seismological Institute, which can give back the data regarding an earthquake so that fast action can be taken in case of an earthquake. Next slide. Apurba, you are mute.
So, sorry, I was on mute. Coming to the affordability, we have tried to use the most value for valuable materials that are the hollow concrete blocks and the that is used for the walls. And coming to the energy consumption, uh, we have s- we have s- we have used solar panels to produce electricity, and the overall cost that is there. So the total payback period is for 4 years to overcome the cost. Uh, Coming to the scalability and market potential, the number of doctors and nurses that are living in the houses block are potentially increasing in the future. So to increase in the number of residents, new housing blocks can be constructed on the site, and also the floor levels of existing housing blocks can be increased. Uh, Coming to the marketing potential, the housing block has 120 mm, 121 BHK and approximate 240 people staying in there. So due to that more people in housing block, we have set a commercial complex including vegetable shops, grocery shops, restaurants, cafes, and etc. Also, the market potential can be realized in the form that uh, uh, general public there for general public, as lot of patients, doctors and nurses, staffs and students and security guards are also visit them. In the innovation part, we have used the modular construction and the advanced windows control system for yeah. And we have used a self-healing road uh, that can cut off 50% damage repair cost that in the near future, and 16% lower emission and of carbon, and 32% lower cost commitment. Yeah.
Coming to the solid waste management system, this is the septic tank sewage treatment plant, and water treatment has been done, and the STP sewage treatment plant, the solid waste has been separated, and it goes to the equalization tank and the sequentially batch reactor tank, and then drying in the sand and the aerobic digester in which air is got oxidized, and the slurry tank in which ammonia is mixed, and then the rest of the part is converted into fertilizer and then sent to the grounds. And the solid waste management for the residential building is being divided into two parts: biodegradable waste and the non-biodegradable waste. Biodegradable waste is further divided into food waste as well as the food waste from the open area, where food waste from the open area directly goes to the composting part, and the food waste has been divided into two: cooked and uncooked. Uncooked food has been goes to the animal fodder, and the cooked food goes to the composting and all that stuff. And then the non-biodegradable states have here different varieties, but everything goes to the material recovery faculty, and all these are the responsible things for the environmental, social, and economic.
Thanks, team. Thanks for your presentation.
Thank you
We'll,
everyone for
yeah. So now we'll have our jury talk about what they saw in your presentation.
I think one of our teammate is in the backstage. Can you let him in?
Yes. Yeah, all right. Jitin, we'll start with you this time.
Yes, thank you, Srijit.
Yeah.
Once again, a good presentation. All of you have done a good job. Uh, Unfortunately, time was not less, but you are not able to complete. That's fine. Don't worry about it. Uh, Overall, again, comprehensive. Lot of work you guys have done. Only two things I have. One is that I noticed in one of your slides that the building levels were changing. Why is that?
So
Building
because the
levels.
site is on the contours.
Okay, contours. Okay, okay, great.
Yes, sir.
So your plan responds to your contours. Good.
Yes, sir.
Probably you could have showed it in your plans also, but it's good that it's responding to your site. Another thing I noticed, I think in your EPI calculations or just after your EPI calculations, you mentioned, just go ahead further. Here. No, no. Those two graphs uh, for temperature. Yeah, this one. Here you mentioned that in afternoons the HVAC is not used as it is considered to be vacant, right? The house is considered to be vacant.
Yes, sir.
Now, afternoons is when it is going to get hottest, right?
Yes, sir.
And sometimes you may have some people staying over, or it might be
Sir,
Saturday,
our
Sunday.
main concern for using the HVAC is for the cold climate, cold time, not for the hot time.
Okay.
So hot time, it's like we have the comfort zone in our building with using ventilation and the windows open.
Okay, fine. So that is comfortable in
Yes, sir.
daytime. Oh,
Yes, sir.
great. Okay, that's it, huh? So over to you, Srijit, and great work, guys.
Yeah, thanks, Jitin. Samit, what about
Yeah, thank you, Vijit. Thank you, Team Sub Zero. Good effort. I have a few observations and again, in your, I think one of the slides probably is like 28 or something.
Yes, sir.
So where in your building, if you open a floor plan, where in your building is an issue, where you plan your BOS system.
But
Yes.
it's okay.
So that's what I was trying to. That's what I was trying to bring your attention. Actually, when you're proposing a otherwise, be a lot of conceptual stuff. Then not clear not to just bring in the ideas. You should start thinking of how to make it buildable. And I think that's what I'd like you to focus on.
So in the very next slide, I have mentioned the areas which I have used my HVAC system in. Like this one, these are the spaces which has been used with the HVAC.
Understood. But where do you keep the equipment? So have you seen an AHU? Have you tried to figure out how to sort of locate one? I mean, we
Yes, sir. It
struggle
has
we
to be.
struggle with this every day. I think between engineers and architects, we're struggling every day to locate AHU. So it's a difficult thing. So in a residential space, is even more difficult. So that's why I was just
Yes, sir, I
keen
just
to
know
understand.
theoretically that it needs to be placed somewhere
Right.
on the top. Yeah.
Yeah, yeah. So a little more effort, guys. That's what I sort of wanted to put in. And you got the
Yes.
concepts in, you got the ideas in. Take it through. That's my advice.
Sure, sir.
Right. Thanks. Back to Srijit.
Yeah, thanks, Amit. Dheeraj, you want to go next?
Yep. Thank you, Srijit.
Yeah.
Uh, Three, four things which come to my mind as I speak. One is first is the question which I would like to ask. Uh, did we achieve net zero on water? I did not see that. Anybody can answer?
Yes, sir. We have achieved like we are getting 65% of water demand from the rainwater harvesting part, and then for another 6 months we are borrowing water from municipal corporation.
So we are not achieving is my question, right?
Yeah,
No problem. That's
like
okay. See,
we
that's what.
are using, like if we consider the groundwater recharge part, the amount we are borrowing, we are letting water into the groundwater recharge that we are borrowing. More than we are borrowing, we are letting the water into groundwater recharge. If we consider that, then it will be a net zero.
Okay, I take your point. Second question out here, what I have for you is I observed one very, I'll say, a dynamic effort from your side, considering the um, ground source heat pump approach. Okay, that's not an easy one. We have one of the jury members on some other criteria of evaluation. He has been actively working on that side. I feel, considering the number of hours you have on heating, close to 900 odd hours and about 600 for cooling, if I remember correctly, in the 8760.
Yes, sir.
Considering that fact, I am of the opinion, basis my experience, that your ground source heat pump option should work out better as compared to VRF systems, which is going to be very high on heavy on capex and will not give you as much payback as what a ground source heat pump can give you for this application. Particularly, if you convert this into a chill water system for this application and do not look into a DX system for this application, just evaluate. It's a good project which you have laid your hands on. It's not an easy one. I don't know, on a lighter note, who amongst you belongs to Nepal and pulled you up for this project, and my compliments to you for that. Happy to see that efforts are being made outside of India as well, and I think jury and everybody in Solar Decathlon will be happy to contribute as well, through ideas and thoughts. So these were primarily the two things which I had in my mind, which I wanted to share with you. Thank you so much, and appreciate the hard work done on this project. Thank you.
Thank you, sir.
Thank you, everyone.
Yeah, thanks, Dheeraj. Actually, this is one of those projects which are the first in Solar Decathlon India to have a site outside of India. So uh, we were also very excited when we got the first deliverable, and the site was Kathmandu. So we were also very excited. Yeah.
Sure.
So okay. So thanks, team, so for your presentation. Next, we have a half an hour break. We'll join back again at 4:30, and we have one more presentation, which is from Team Suki Baba, and we'll join you guys back after the break.
All right.
Sure.
Thank you.
Yeah.
Thank you.
Okay,
Thank you.
thanks. Thank you.
वो तूफान क्या है जो डरते हैं हम आने से, वो मंजिल है क्या जो डरते हैं हम पाने से, वो तूफान क्या है जो डरते हैं हम आने से, वो मंजिल है क्या जो डरते हैं हम पाने से। जिंदगी है कुछ करके दिखाने से, पीछे मुड़ने से, आगे बढ़ने से। हम जीरो है क्या, हम जीरो है क्या, हम जीरो है क्या, हम जीरो है क्या। Team Nevas 2.0, Team Nevas 2.0, Team Nevas 2.0. Let's sustainably grow, let's sustainably grow, let's sustainably grow. नींद आँखों से उड़ जाए, जब तक मंजिल हासिल न हो पाए। इतना जुनून है सीने में, इन आँखों में, इन ही रातों में हम जीतेंगे। Team Nevas 2.0, Team Nevas 2.0, Team Nevas 2.0. हम हीरो है क्या, हम हीरो है क्या, हम हीरो है क्या, हम हीरो है क्या।
So welcome back, everyone, after the break. So we are moving into the final presentation for the multifamily division housing, a housing division category. So our final presentation is from team Sukhi Bhava, and they have worked on a project Pragya 2 in Gift City, Gujarat, and their project partner is Savi Infrastructure Private Limited. So let's do a quick A/B check for our presenters. Himabindu, can you unmute yourself and say something?
Can you hear me?
Yes, very clear. Abhinav?
Yeah, am I audible?
Yes, loud and clear. Shekhar?
Hello, sir.
Yeah, hi. And we also have team member Mojesh.
Yes, sir.
Mojesh, could you say something?
Yes, sir. Hi, sir.
Great. Okay. So can you start your sharing your presentation and go into presentation mode?
Yeah, yes, sir. Yes, sir. Ready.
Can you go into slideshow mode?
Yeah, you're not getting it. One second, like I will represent it. 1 second.
Yeah.
Is it okay?
Yes. Cool. Great.
Yeah.
So team, you will have 25 minutes to do your presentation. At the end of 20 minutes, I'll ring a bell like this. You heard that?
Yeah. Yeah.
Yeah. And you won't have a 26th minute, which means that at 25 minutes, it's a hard stop. I'll need to stop you and ask you to end your presentation. After that, we have a 15-minute Q&A session with our jury members, and they'll provide some comments and feedback on your presentation. Try to keep your answers direct and to the point and very succinct. So team, the stage is all yours. All the best.
Thank you. Good evening, everyone. I would like to welcome all the participants, audience, professionals, and the honorable members of the jury to our division jury presentation. Mojesh, Shekhar, Himabindu, and myself, Abhinav, are here today to present our work on behalf of our team, Sukhi Bhava. Our project partner has provided us with the opportunity to work on a 20-story high-rise residential apartment with 80 dwelling units titled Pragya 2. So, next. We are provided with a brief from the project partner with a few specific features to be included, such as privacy between occupants, common amenities, beautifully designed outdoor spaces, covered car park, etc. Site context. Coming to the location of the project, it is located in Gift City, Gujarat, which falls under hot and dry climate zone and a seismic zone 3. The maximum outdoor temperature is 44 degrees Celsius and it receives an annual rainfall of 769 mm. And these are few proximities to the site. Next. The site is located at Block 16E of 1.18 acres with a permissible FSI of 3.65, out of which we attained 3.52. The water body named Samruddhi Sarovar is situated right opposite to the site, and Tapas Udyan, the city's green garden, is on to the northeast. Next. As Gift City is a greenfield project, all the vegetation, public parks, pedestrian walkways, and road networks are all well planned. Majority of the stakeholders for our project will be the working employees in the city, and the targeted user groups for our project are MIGs and upper MIGs. Coming to the climate study, a heat map has been generated to identify the uncomfortable annual hours with temperatures above 28 degrees Celsius. and a windrows diagram has been generated to identify the directions in which the comfortable winds flow. The inputs given are the wind speeds to range between 0 to 10 meter per second, with the temperatures between 22 to 28 degrees Celsius, with a humidity range of 25 to 60%. And using the IMAC tool, percentage of the operational modes of cooling were estimated. Next. Air quality has been assessed during different time periods, and on an average, the AQI lies around 95, which is satisfactory compared to the other metro cities. Next. A psychrometric chart has been generated using climate consultant, and selective strategies were implemented for achieving thermal comfort. The target thermal comfort range during the winters are 22 to 26 degrees Celsius, and during the summers, it is 25 to 27. Conceptual development. Various iterations were developed, and the final iteration comprises the positives of all, such as in the first one, there is an ease of public traffic with 2 split circulation cores. From the second one, cross ventilation. In the third one, the staggered formation along the with shaded garden areas onto the north. In the fourth one, the block has been further spread across the site, reducing the excess heat gain by having circulation onto the south, but resulting in reduced privacy and increased views. In the final one, the blocks have been cut out and added, creating the circulation course between 2 units each, easing the public movement, while providing the views both onto the city and the water body with proper ventilation. In parallel to this form development, various simulations were done on the mass blocks, out of which major stages were included here. In the final design block formation, you can clearly see the self-shading happening onto the south due to the staggered formation. Zoning. So the block formation, reduced radiation, everything's fine, but ultimately it's the user experience that matters, because they are the ones who's going to pay for it. The zoning of the flats has been done considering all the contextual aspects as well as the user experience. An open floor plate has been made so that even the guests can easily move around and take a look at the beautiful views, so that it is not limited to the family itself. The living areas have been made glare-free, where they could enjoy their mornings with pleasant views overlooking the garden and the Tapas Udyan. The utility and the service spaces are oriented towards the southwest, acting as barriers to the excess heat gain. The staggered block formation has helped in cutting down the harsh winds from the southwest regions with higher wind speeds. Next, architectural design. So this is the site plan, and the access road to the site has been made one way to avoid the vehicular conflict. We have also made sure that pedestrian-vehicular collision has been avoided, as the pedestrian movement happens onto the above portion of the site, and the solar PV system has been set up onto the south. The area under the solar PV systems can be utilized for emergency parking. Next. Basement plans. Apart from parking, we have the provision for the electrical room in basement 1 and the water storage, pumping systems, and the STP at a double floor volume. Next. The ground floor hosts all the common amenities and has a ramp access to make it universal design. And it also has multiple entry points to split the public movement. The server room is also set up in the ground floor for handling the building management system. Next. Odd floor plan. So 2 3 BHK units were placed on both ends of the floor plate, and the 2 2 BHK units are placed in the middle. Each unit has been specifically designed in response to the context and the user experience, but the basic principle remains the same, such as the living rooms in the 3 BHK units on either sides and the 2 BHK units are all placed onto the north, and the majority services are onto the southwest region. Next, even floors. The 3 BHK units and the structural grid remains constant, wherein the 2 BHK units were replaced by the 4 BHK and 1 BHK units. Next. Workspaces. These days, we have been seeing a lot of work from home which is happening. So a provision for dedicated workstation has been integrated within the bedrooms to maintain healthy connections with your co-workers as well as your family. Next, garden spaces. The garden spaces are designed such that they receive sunlight during the mornings and are shaded throughout the day. Various shadow studies were done on site during the winter mornings, winter evenings, summer mornings, and summer evenings. Next, the facade of Pragya 2. The facade is designed in an aesthetically pleasing way, breaking the rigid geometry in order to attain the dynamic character to the form. Next. These are the views that I was talking about earlier. The glare-free balconies onto the north with a view towards the city, and the shaded balconies onto the south with a view towards the water body. Next. Envelope optimization. Hollow AAC blocks are used for the walls for taking advantage of the air-gap thermal insulation as well as for structural purposes, which is sandwiched between plaster and is coated with SRI 130 paint on the exterior side. Coming to the windows, though we could have gone with the higher insulation glass, about 1 watt per meter square Kelvin, we chose the ones with a standard value of 1.63 with a 12 mm gap of argon EN673. Because argon gas is about 40% denser than air, adding it improves thermal insulation efficiency, and this helps to bring the temperature of the window close to the room temperature. Next, Sajja orientation. Sun charts have been generated, and it is clearly evident that majority of the shading is required on the southwest oriented glazing. So the chajjas are placed on the southwest regions with the VSA angles of 70, 60, 56, and 44 degrees respectively, and the chacha protrusions vary between 0.4 to 0.7 meters. Next, daylight analysis. Daylight illumination has been simulated, and a median of 334 lux levels is achieved on the floor plates. The overlaid spaces which are indicated in red are the balconies and the lobby spaces which are exposed. The habitable spaces receive 100 to 300 lux, which is ideal for residential units. And how do we prove that? Daylight availability. Next slide. Spatial daylight autonomy of 87.5% is achieved, which is the floor area that receives over 300 lux for a percent of 3650 annual hours, which is 10 hours a day. Annual glare. 15.4% of annual sunlight exposure is achieved, which is the floor area that receives over 1000 lux for 250 hours. And all the spaces that receive the intolerable glare are the balconies and the lobby spaces. And more than 95% of the habitable spaces are glare-free. Energy performance index. An EPI of 26.11 kilowatt hour per year per meter square has been achieved by using energy efficient elevators, pumps, home appliances, 5-star split ACs, LED motion light sensors, and solar water heaters. Next. On-site renewable energy is generated using the solar PV systems. Our 3.7 kilowatt solar array on the roof and site enables to live entirely on the solar energy, making it net zero energy. Building energy offset of 109% is achieved. The excess electricity generated is given back to the grid, and in case of power outrage, the supply is taken from the power grid. Next. Innovation. During the peak summer months, the sun is slightly inclined towards the north, unlike its usual inclination towards the south. So a tensile canopy has been designed to protect the living areas from the sun. The data inputs for the simulations are during the months of April to June between 11 a.m. to 4 p.m. The width of the canopy varies between 4.5 to 5 meters across the stretch. And this is the human level view to the canopy. Next. Water pressure systems. Dual mechanism water equalization system is used to maintain a fixed water pressure across the building. The water is first supplied to the overhead tank, from which the booster pump is used to increase the water pressure at the higher floors, and the pressure reducing valves are used to reduce the water pressure at lower floors due to gravity. Next. Invisible grills. These grills are provided in the balconies to provide safety and unobstructed views for the occupants. These grills are made up of stainless steel of 316L grade with a coated membrane for added wear and tear resistance. Next. Health and well-being. As per research, green spaces helps health in various ways. Even viewing scenes of nature could have a positive impact on the individuals. It not only improves your emotional well-being, but it also benefits your physical health. Who wouldn't aspire to live in such a home? So move into your new neighborhood, we would say. Next. Solid waste management. GIFT's automated collection and transportation system of solid waste has been utilized by Pragya 2. Next. First, the waste is collected, then segregated as organic waste, plastic waste, etc., and then dumped into the waste storage point through the chute system. For transporting the waste to the treatment plant, the waste is sucked by vacuum at a speed of 90 km per hour. Next. Indoor thermal comfort. So the bottom graph here showcases the annual indoor room temperatures and the relative humidity of the floor plates. The temperature range falls between 21 to 27 degrees Celsius, which is the desired comfort range, but the humidity exceeds the required amount of 60% during few months. Also keeping in mind the future climate change, the dehumidification can be done by mixed use of ACs and mechanical fan cooling to achieve thermal comfort. And the above graph showcases the same but in a zoomed in view for the peak weeks of the year, during the peak weeks of the year. Next.
The next major challenge was to achieve an efficient water performance. So we followed the triple R strategy, that is the reduce, recharge, and the reuse. Coming to the reduce case, the water consumption was brought down from the base case of 135 LPHD as per NBC to 75 LPHD by usage of efficient water fixtures, front load water washing machines, and low flow aerators. This allowed us to reduce the water consumption by 44%. The next scenario, that is the recharge scenario, the roof next. The roof of the building is utilized as a catchment area for the rainwater. And in the case of hardscape and softscape zones, the water is collected via stormwater drains, which is deposited in an underground tank. And a rainy FL 500 filtration system is used to remove the dirt and impurities with more than 90% efficiency, which is deposited in the same underground water tank, which is later transferred to an overhead tank, which distributes the water for the domestic use. Coming to the next R, that is the reuse case, as we can observe that the building generates around 25.3 kiloliters of grey water and 8.37 kiloliters of black water every day. The grey water collected is collected in an underground tank where it is sedimented and anaerobically treated and filtered by a planted gravel filter, which usually filters by a 75% efficiency. This recycled water is being used for flushing, irrigation, and PV maintenance. Coming to the water discharge from the flushing, it is treated in an STP situated in the basement of the building. And also, we try to concentrate on the fire safety, where the water is first pumped into a dedicated fire tanks. Later on, when these tanks are at full capacity, the water only then overflows into the daily use of domestic tanks that supply water to the apartment. The gift city is designed for around 15 days of drinking water storage. In case of any emergency lockout, the water storage has been made for 1.5 days for essential use of the occupants like cooking, drinking, and washing. Next.
Coming to the resilience part, Gandhinagar city falls under the Zone 3 on the seismic zoning mapping of India, where an earthquake of magnitude 6 can be expected. So the risk of having earthquake is considerably moderate. Hence, the structure is included with shear wall system, as the system provides adequate stiffness to the structure, and the core system is supplied at the heart of every two flats, each of which comprises of vertical circulation systems. Due to the building's high-rise typology, shear wall is used to construct the lift core walls. This allows structure to be built rapidly using the same framework and at a lower cost. And longer columns, which act as shear walls, are used between the floor plate without intrusion into the living areas and all. Next. Fire protection systems are an integral essential aspect of residential habit design. The fire safety systems are designed and installed as per National Building Code of India. Multi-detectors and smoke detectors are installed inside the floors. These are planned according to that if an accident happens inside a kitchen, only the kitchen floods, not the rest of the flat, like it happens usually. And the walls shown on the right side of the image, the red walls, are all are separated from the residential units to provide fire resistance with no less rating than 4H for making the occupants to easily escape from top to the bottom of the building. Next. And all the vegetation areas are actually planned towards north side of our site, and because of the prior iterations that we have done, the building actually protects the north part of the area, and we have placed all the solar panels on the south side. So yeah, we have a lot of recreational areas and other vegetation areas on the north, so it's even protective for the future scenarios. Next. To achieve an net zero building, passive design and also selection of five-star equipment is very much important. So we actually analyzed various products on the market which are very essential for building, and we have selected like equipment which only has five-star ratings. And we have also proposed solar water heaters which act as renewable energy sources. And we have also used motion sensor lighting in areas like lobbies and lift spaces, so where the public movement is not very frequent. Next. Each of the occupant in the building will be provided with a phone app where he can monitor his electricity, water, and other bills. He can even know where his electrical vehicle is parked and all. This mobile app is connected to a building management system which is located in the ground floor of the apartment, and this has its own sensors in every floor, and like it monitors things like securities, fire smoke alarms, and other automatic features that are involved in the building. Next. Coming to the affordability part, we have actually met few industry partners. So for us, we use slender beams and columns for the structural system because we thought of my technology at the beginning, but it would not return the capital cost that we put on the investment. So we finally came up with slender beams and columns. This function expands the flat carpet area. Also, of the electric fixtures are concealed in the slab, making the cost of ceiling to be reduced and unnecessary functional purposes. This gives the occupants the option of lowering the ceiling cost while commissioning the interiors of the flat. In addition, because these columns are hidden in the wall, brickwork is reduced, which results in 30% savings. And also, cost reduction is achieved through steel. The load of the base structure will be very great due to the above floors acting on it. So we have actually used 32 dia bars in the lower floors, and gradually with the increasing floors, we have gone to 16 dia bars in the toppermost flats of our apartment. This actually considerably reduced the steel cost that we used in the building. Next. Coming to the scalability, uh, the best possible solutions which took into account a variety of performance factors was for 3 BHK to have two different types of modules, 2 BHK to have two types, and 4 BHK and 1 BHK of one types. Next. And because of the structural grid remains constant, if the program requirements change after we started construction of the project, uh, even and on floors can be repeated according to the user requirements. Like suppose if the demand for 1 BHK has gradually increased, then the project partner, the construction man can actually repeat his even floors and odd floors.
Market potential. The project site is fortunately located in Gift City, which has immense scope to become one of the remarkable cities in India. And also, it is well connected to the nearby airport, railways, and metro, which is under construction. Based on the IRJet research work done at the end of 2021, from all the responses received, 57% of the public prefers to buy high-rise property between 10 to 20 stories. And these are few salient features of Pragya 2. Next. So before ending up, let's quickly have a summary regarding the 10 contests and the highlights of the project.
And here is a team with 14 members, like a team of 14 members, and these are our faculty who helped us through all this 9 months of our hard work and like any mistakes we have done. Thank you.
Wow, that was a very interesting presentation, guys, and uh, great job, I would say. So let's hear from our jury members. Samit, you want to go first?
Yeah, thanks, Srijit. Team Sukhi Bhava, I think that was super presentation. I think you shouldn't have left
Thank you.
the summary without a voice button. It was sort of very engaging till you reached the summary and you just left it hanging. Probably should have used a voiceover. But I think excellent work, excellent presentation. Just a few small observations. Again, I'm just drawing your attention to detail. For example, your slide 23 shows an air gap in the roof section. If you pull that up and check that, I'm not sure if that works or what you had in mind, or that is an error. What do you what was in your mind?
Can you reshare your screen? Yeah, great.
Slide 23, as far as I remember. Yeah, so I think 60 mm concrete and there's an air gap and concrete. So how do you pull this off? Anyone? No?
Samit, maybe do you want to reiterate your question in a different way?
Yeah, I mean, how do you have you thought through this thing and how do you make a concrete roof with an air gap in between? How do you sort of build it? How do you make this feasible? You've used it to reduce your U factors. So how do you make this happen? Is the question clear or?
Yeah, yes, sir.
Yeah.
So actually, there is a mistake. It is like a cast slab. It doesn't have any air gap. So
Alright.
initially we thought we should have a ceiling. We shouldn't have a ceiling because the roof. Nowadays interiors are going without ceilings. So it's a lot of exposed roof. So there was
Right.
miscommunication between us. So one of the graphic person thought he wanted to conceal all the electrical fixtures and all through this air gap. So it wasn't actually that. It was a simple plain slab.
All right. So again, so like I'm saying, the important thing is your attention to detail, taking an idea through. And I've been repeating it throughout the day, but that's the important thing here. Also, find your idea of the canopy interesting, but I think the canopy gives an unfair advantage to the floors above. If you see your slide 31, I think your occupants below will grudge the fact that they don't have the canopy above them. So that's something which is also something which I'd like you to think about. But otherwise, an excellent effort. I mean, really fantastic presentation. I wonder who worked on it, but excellent work on the presentation. Thank you very much for the good work. Back to you,
Thank you.
Srijit.
Thanks, Samit. Dheeraj, do you want to go next?
Sure. Thank you. And I'm really amazed with this great presentation. The report, what you had shared, what we went through, and your presentation today is a complete blend in continuity. I don't see a gap of what you put in your report and what you spoke today. That's really admirable, is one comment from my side. And your idea of water pressure being managed from floors above to the floors below, I think that's a novel idea, and I find that a little different than as compared to what I've seen till now in many reports. So do appreciate your thoughts around, at least finding something different, new, innovative, and real effort in that side. And with that, I mean, you're not left me personally, at least, with any question to be asked. Thank you so much, and great work done. Appreciate it. Thank you.
Thank you, sir.
Thank you, sir.
And
Great.
Rohit, to conclude, please do congratulate all your team members who possibly, because we have a rule of 4 members, could not join you. But I know that all of them would have worked really hard with each one of you. Thank you.
Absolutely. Thanks, Dheeraj. Chetan?
Yeah, excellent presentation integrating sustainability with architecture. So I'm very happy to see that. You also, presented and analyzed passive strategies. Your service is also very well. So overall, it's great work. And lastly, your flexibility or flexibility of the apartments modules that you've made. All the best.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thanks, all the jury members. So great presentation, team. We heard it from the jury themselves. So thank you so much, and we wish you all the best. Now let's just wait for our jury members to kind of decide the winners and runners-up. So that was our last presentation for the day for the multifamily housing division. So I want to first thank all the jury members for showing this dedication to assessing these entries. I want to thank them for their thoughtful assessments and comments. And I want to specifically congratulate all the finalists and a huge round of applause to them. As yeah. As the jury coordinator for this division, I had this opportunity of seeing these teams submit some really good work, starting from deliverable 1, 2, 3, and finally now 4. There was some really incredible work that was done, and let's not forget that these teams did not do it maybe in person; they did it all virtually. They found a new way to collaborate and do integrated design. Um, and doing this for a period of 8 months is, I think, a big deal, and that itself, I think, needs a big round of applause. So this evening, our jury members will meet and decide who the winners are and who the runner-ups are. So who will that be is the question to be answered. Meanwhile, I hope that all of you have were able to give your votes for the People's Choice Movie Award on YouTube. And feel free to hang around the platform and meet the jury members, exchange business cards in the quick networking lounge. And then at the last, we can see that all of the work these finalist teams have done is being hosted on the project exhibit hall. So you can access that from the main lobby. So we'll see you all tomorrow at 10 a.m. for another exciting day. Tomorrow is going to be awards and then grand jury, which I'm really excited for. So thank you everyone. Thank you so much for joining.
Thank you.
Thank you.
Yeah, thank you.
Thank you.
Srijit, we also log out or we stay back?
You can stay back for a couple of minutes.
Sure, okay.